This is RD Sharma solution. We are taking probability of class 12th. The exercise is 31.5. A bag contains 6 black and 3 white balls. Another bag contains 5 black and 4 white balls. If one ball is drawn from each bag, find the probability that these two balls are of the same color. So in order to understand this, let's make a figure. So this is our first bag. This one is another bag. So we have 6 black and 3 white balls here. How many in total? 6 plus 3 is 9. In the second bag, let us call the first bag, the bag as 1. Second as 2. In the second bag, it is given in the question 5 black and 4 white balls are present. The total in the second ball also counts to 9. Now if one ball is drawn from each bag, so when you draw the ball and the other ball from the second box of bag, these bags are independent. So whatever you draw from one is independent as or has no relationship with the other one. And similar for the second one also. So the first one black, second black. First one white, second one white. First one black, second one white, and first one white, second is black. So these are all possibilities that can come. So let's write it in a formal way. B1, B2. First black and second black. First white, second white. First black, second white. First white, second black. White and black are the last one. So these are only 4 combinations that can come. Now the two balls are of the same color. That is, same color means except this B1, W2 and W1, B2. Others we require. Same color means black, black and white, white. So the first and second. So this will be how it will be written. Probability of both balls are black and probability of both balls are white. So both black, both white. First and second are the actual favorable cases here. Ball of same color. What does it mean when we write both black? It's basically B1 and B2. And means intersection. So we'll write probability of B1 intersection B2. These are independent events. So we can write PB1 multiplied by PB2. Similar for the second logic. Probability of both white. So PB1 intersection B2. And second one is both white. So W1 intersection W2. That is either of the whites or first white and second white. So we have PW1 multiplied by PW2. So this PW1, PW2. So we have PB1 multiplied by PB2 as the first one, and second one PW1 multiplied by PW2. So we need to find out the probabilities now. So probability of getting a black and probability of getting a white in the first one. I'm writing it as B1, V1, the W1 just to represent that they are coming from the first bag. 9 remains in the denominator because these are total cases. Blacks are 6, whites are 3. So 6 by 9 and 3 by 9 are the probabilities for the first bag. Second one again, PB2 and PW2 we are writing. Denominator remains the same. 5 plus 4 is 9. So the total number of cases are 9. What are the favorable cases for black in the second bag? It's 5. Let's write 5. The second one is 4. Now we have got all the values and we are going to write it here. PB1 is what? 6 by 9. PB2 is 5 by 9. PW1 is 3 by 9. And PW2 is 4 by 9. So 30 by 9 9s are 81. 4th is a 12 divided by 9 9s are 81. So 42 by 9 into 9 has come. 42 by 81. Now these are multiples of 3. So you get 14 divided by 27. 14 by 27. Now what I told you was quite in detail, but this is how you're going to write it. If you have less mark carrying question like this, otherwise you have to explain everything. A bag contains 3 red and 5 black balls, and a second bag contains 6 red and 4 black balls. A ball is drawn from each bag. Find the probability that one is red and the other is black. So here we have the first bag, 3 red plus 5 black. First one is this one. Second bag is 6 red and 4 black balls. 6 R and 4B. A ball is drawn from each bag. One is red and one is black. The probability needs to be found out. From the first one, red can come. The second can give also the red. So R1, R2. 1 and 2 represent first bag and second bag. First one gives red. Second one gives black. First black one comes, second one red, and first black and second also black. So these are the four combinations or four possibilities that can come. One is red and other is black. So one is red, one is black means it's not given that first has to be red and the second has to be black. It is given red black or black red. So we will take the second and third options here, R1 B2 and B1 R2. So the first one is saying one is red and means intersection, one is black. So what is this probability? Probability comes like this, red and black. So probability of red and black, red 1 and black 2, but black and red can also come. First one red 1, second one black 2, this already done. Coming to the second part, which is first black and second red. First gives us black, so let's call it as black 1, and second comes the red, so red 2. This is B1 intersection of R2. Now these are independent events. We can write it as PR1 multiplied by PB2. Here we can write PB1 multiplied by PR2. Now let's find the probability. So the probability of R1 will find out, B1 will find out. Total number of values are 8. So 8 goes in the denominator. Here also we'll find PR2 and PB2. 1 and 2 representing that they are coming from first and second bags. Total is 10 in the second case. Total is 8 in the first case. That's why I have written everything in the denominator. These are total number of cases. Favorable cases for red in first is 3, black in first case is 5, 6 in second bag and 4 in 10 bag, red and black respectively. Now as we have found out the probability, we'll just replace it here. 3 by 8 for PR1, B2 probability 4 by 10 plus 5 by 8 B1 probability, and R2 probability 6 by 10. So this becomes 12 divided by 80 and then plus 30 divided by 80. So this becomes 42 by 80, and when you compute this it will be 21 divided by 40. This is your final result. So this is how it will be done, but if this question carries more marks, then the explanation I gave should also be incorporated or be considered. 2 balls are drawn at random with replacement from a box containing 10 black and 8 red balls. Find the probability that both the balls are red. So we have a box. In this we have 10 black and 8 red balls. Now we have to draw 2 balls with replacement. That is, this is the condition. This is the question of independent events. If replacement is being carried out, this is the question. No replacement, conditional probability question. So both are red, that is first black can come, second can be red, then red can come from the first drawing, and the second will be black. First black, second black ball, and both the balls which we are picking up are red. So these are 4 possibilities. So let's call it as 1 and 2 because there are 2 balls being drawn one by one, or say simultaneously also, together also. Now probability of red is, in both the ones are only R1 R2. It can be R2 R1, it can be R1 R2. They both are same. So these are independent event. We can multiply them separately. So PR1 multiplied by PR2. And what is the PR1 and PR2? See, the R remains the same. Probability of red remains the same because there is a replacement. I am writing it separately, but they are similar. PR1 and PR2 are same. The denominator is, total number of balls are 18. So write that in the denominator. Numerator has how many? 8. So 8 by 18. So 8 by 18 and 8 by 18. You will get 16 by 81. Basically it's 64 by 324. So this was a very simple question that can be followed. 3.2 also will be done in the similar way. Now we have again the same box which contains 10 black and 8 red balls. We have to find out first ball is black and second is red. Now there are 2 balls being drawn. The first one can be red, second can be red, first can be black, second can be black, first can be red, second can be black, or both can be. So these are both red, both black, then the inversion, that is red black or black red. I'm writing it as 1 and 2 just to show that these are 2 separate balls. But since the replacement is being taken care, and we have to find out that the first is black, it's fixed that first has to be black and second has to be red. What is the probability of getting a black? Total is 18. What is the probability of getting a red? See, it's 18 in the denominator. Please remember, black, B1, B2 or P, R1, R2, the probability remains the same because replacement is going on. What is the probability of black and red together? B1 intersection of R2. That is black coming from the first draw, second draw, giving us red. So P B1 multiplied by P R2 because these are independent events. Probability of B1 we just found out, it is 10 by 18. Probability of R2 is 8 by 18, and this comes out to be 80 divided by 324, which comes out to be 20 by 81. Now this is how this will be done. Now similar question, but here one of them is black and other is red. Same thing. I need to explain all of this. If you have done 3.1 and 3.2, this question will be easier for you. The scenario here is the same scheme. 10 is black and 8 is red. In this, one ball is being drawn, second is also being drawn, and these are independent events because replacement is going on. Whatever is being taken out has been put back before the other ball can be picked up. So both can give you black, both can give you red. First can give you red, then followed by black. First can give you black, followed by the red one. Now the question being asked is, one of them is black and other is red. It's not said that first has to be black and the second has to be red. No, it can be R1, B2, it can be B1, R2. First red, second black, first black, second red, and first red and second black. So let me just change this, the rounding. I have to make this one as the probable inclusion. So P R1 intersection B2 plus P B1 intersection R2. Since these are the independent event, we can multiply them. So let's find out the probability first. Whether the first time or the second time, probability of red remains the same, and this is equal to probability of red 1 and red 2 both. Probability of black balls first or second time. The total balls are 18, so denominator will be 18. Here also first black or second black, the denominator remains the same, it will be 18. And what is the favorable cases for red? There are 8 reds, so 8 by 18. Black are there, so 10 by 18. Now these are independent events, so we can write them separately. PR1 multiplied by PB2. First red, second black. Here first black, second red. So PB1 multiplied by PR2. What is PR1? It's 8 by 18. So these both probabilities, PR1 and PR2, as I suggested, they remains the same. So 8 by 18, 8 by 18, I'm writing here. PB1 and PB2 also remains the same. So I'm writing it here 10 by 18 and 10 by 18. So when you compute this is just twice of 8 by 18 multiplied by 10 by 18, which gives you 80 by 324 two times. This gives you 40 by 81. Now this is how this will be done. And this is a good question, and these are 3 parts actually we have done. 2 cards are drawn successively, one by one, without replacement. Now without replacement is very important. With replacement, without replacement. From a well shuffled deck of 52 cards, probability exactly 1 ace. Now there are 52 cards in all. In this we have 4 aces, exactly 1 ace. So first ace can come, first card, there are 2 cards actually. So first will be ace, second can be any card. The second possibility is the first card can be any card, the second card should be an ace. Now there are 4 aces. How many aces? 4 aces. We are having 52 cards. So 4 aces are there. 52 cards in all. Now second card can be any of this card. One is already been taken because there is no replacement. So we are left with 51 cards. 52 minus 1, 51 cards. Now you don't want an ace. 52 cards are there. 4 aces are not welcomed here for the second card. So in 52 cards, if you subtract 4 cards, how many cards are left? 48 cards are left. So this 48 are the favorable cases. Now in the second case, first card can be any card except ace. So in all 52 cards, you have to subtract 4 in order to get the favorable cases. So in 48, without the ace card, divided by the total number of cards is the probability of getting a card other than ace. In 52 cards, one has already been taken out. So 51 are remaining. But the first card is not an ace. That is confirmed. So that means 4 aces are still there. So there are 4 aces. So this is the probability of getting non-ace and an ace. First is ace and non-ace. Now this is the logic. But how about writing? So this probability which we are going to find out, or we are finding out, is P exactly 1 ace. So this is equal to probability of first card as an ace plus from here to here, what is the probability? Second card has to be an ace. First card can be any card other than ace. So when you compute this, 52 into 51 in the denominator for both of them. So actually you have to compute 4 into 48 plus 48 into 4 divided by 51 into 52, which comes out to be 32 by 221. So this is very important, with replacement and without replacement. Now this is how you need to write it. Actually this is sufficient in order to write, or in examination this is enough for you. But if you give more intricacy, it will be better. A speak truth in 75% and B 80% of the cases. So 75% of the cases A speaks the truth and B speaks 80% of the time. In what percentage of cases are they likely to contradict each other in narrating the same incident? So they are two persons, and the input is given is 75% correctness for A, 75 by 100. That is the truth of A is 75%. The second person says truth 80% of the time. So 80 by 100. So 0.75 is the probability of A speaking the truth. 0.80 is probability of B speaking the truth. Now, when first speaks truth and second says false, this is the first condition, because they needs to contradict each other. If one has to say yes, other has to say no. So first says yes, second says no. T1, F2. One is for first person, second is for second person. Or first say these first false and second say true. So if we say that T1 is the truth for first one, T2 is the truth for second one, F1 is the false of first, F2 is the false for the second one. Truth plus false is equal to 1 as far as probability is concerned. So the false will be 1 minus truth. So false can be computed here for the first person. 0.75 is the truth. So 1 minus 0.75 will be the false. And for the first person, let us represent it using F1. Similarly, for second person, the false, that is the F2, is going to be what? 1 minus 0.8, because F2 plus T2 will also be equal to 1. So F2 will be 1 minus T2, which comes out to be 0.2. So all the values we have got, let's put in here. T1 is 0.75, F2 is 0.2 for the second person not speaking the truth, and first person not speaking the truth is 0.25, and second person speaking the truth is 0.8. So when you compute this, it is going to come as, before writing the answer, let me tell you how you're going to write it, because you have to write it in words. So P, probability of both narrate different incident, means contradict the same event. Someone says that, oh, I had dinner. Second says, no, he hasn't had dinner. That's right. That's kind of example. So this will be equal to A speaking the truth and same time B is not speaking the truth. Or probability of A is not speaking the truth, that is A is false, but B is speaking the truth. So B truth, this will be probability of, in order to write in the probability form, it will be A intersection B not. False is not. A not intersection B. A not is A false. So A not intersection B. These are independent events. That is A and B are independent events. So this will come out to be PA multiplied by PB not plus PA not multiplied by PB. So what is the probability of A? 0.75. PB bar is 0.2 from here. PA not is A is false, 0.25, and PB, truth of B, is 0.8. All these values is what when I was discussing the reasoning. When we compute, is going to come as 0.35. Since it is given in the percentage, it will be 35%. So this is how we are going to write. Now this expression is very important in this case. In this type of question, the question is asking to write you the expression, then only you can write the answer. Kamal and Monica appeared for an interview for 2 vacancies. The probability of Kamal's selection is 1 by 3 and that of Monica's is 1 by 5. Find the probability that 4 different questions are there in this one question. So 1 by 1, what is given or what is the input, we'll write. So probability of Kamal selection, let us call it as A, probability of A. This is 1 by 3. Now Kamal not getting selected is what? PA not. 1 minus 1 by 3. So select and non-select both combined probability will be 1. So 1 minus 1 by 3 it will be. That is going to be 2 by 3. So this is the first case. The second case is same for Monica also. Probability of Monica getting selected or probability of Monica getting rejected. It will be PB, call it as B. 1 by 5 is given in the question, and not selection or no selection of B is going to be what? 1 minus 1 by 5. So 4 by 5 it is. So there are 4 probabilities, different probabilities, which we have deduced from what is given and which we are going to use in computing 1, 2, 3 and 4th part here. The first part is what? Both of them will be selected. That is the probability of Kamal and Monica both getting selected, which is PA intersection B. And since these two are independent events, we can write it as PA multiplied by PB. So what is PA? 1 by 3. And PB is what? It's 1 by 5. So this comes out to be 1 by 15. 5 3s are 15. Now let's do the second one also here. None of them will be selected. So it's simple. A bar intersection B bar. So A is not getting selected, B is not getting selected, neither Kamal nor Monica is getting selected. So these are independent events. So we can write it as PA bar multiplied by PB bar. So what is this? 1 minus PA you can write for PA bar, and then 1 minus PB for PB bar. But these values we have already computed in the beginning. So PA bar we are going to directly write. I'm not doing 1 minus PA. PA bar is already with us, 2 by 3. And this is 4 by 5, which is PB bar. So this becomes 8 by 15. So this is the second one. The third one, at least one of them will be selected, or only one of them will be selected. So we have to write certain expressions. So let's do it. So third one is like this. At least one of them will be selected. So either Kamal or Monica or both of them. That is this. So this will be PA union B, either A or B. So the expression will be PA plus PB minus PA intersection B. And since PA intersection B we have earlier known that they are independent events, it will be PA multiplied by PB. PA is what? It's 1 by 3. PB is what? 1 by 5. And PA intersection B, PA multiplied by PB is what? 1 by 3 multiplied by 1 by 5. So when you compute this, this is going to come as 7 by 15. Now coming to the fourth part. What is fourth part saying? Only one of them will be selected. So if Kamal is selected, Monica shouldn't be selected. And if Monica is selected, Kamal should not be selected. So I'll write the expression first, which is PA and A selected, B not selected. So it has to be AND. APA and B bar, or PA bar intersection B. So A and B bar together, and A bar and B together. That is Kamal not Monica and Monica not Kamal. Only one of them. Now these are independent events. So you can just write PA intersection B bar as PA multiplied by PB bar. And for the second case, it will be PA bar multiplied by PB. PA is what? It's already given in the question. 1 by 3. PB bar we have already computed. It's 4 by 5. PA bar was what? We have already computed. 1 minus 1 by 3, 2 by 3. And PB was 1 by 5. It is already given in the question. So just write 1 by 5. So the final result will be 2 divided by 5. This is the final probability. Now how are we going to write this question in a formal way? So this is how you are going to write it. And I hope you understood also the question, the solution, what I have suggested. A bag contains 3 white, 4 red and 5 black balls. 2 balls are drawn one after the other without replacement. What is the probability that one is white and the other is black? So this is a bag we have, and this bag contains 3 whites, 4 reds and 5 black balls. 2 balls are drawn one after another without replacement. There is no replacement. Mind it. One is white and the other is black. So one can be white, the other can be black. So there are possibilities here. First one is white, second is black. So W1, B2. Or first black and second is white. So B1, W2. In order to write in terms of probability, it will be PW1 intersection B2. This has to go hand in hand. Plus probability of B1, that is the black should come first and white should come in the second part or second drawing. And since these two are independent events, this can be written as PW1 multiplied by PB2 and this as PB1 multiplied by PW2. Now, what in words we are going to write? P, that is probability of 1 white and 1 black. So this will be probability of first white and second black plus probability of first black and second white. So the expression which I have written is exactly what I have written in the words. So let's find out the probability so that we can place it here. How many balls are there? 3 plus 4 plus 5. In all there are 12 balls. Now when we pick the first ball, first should be white. That means in order 12 will remain like that. So this 3 white, so 3 by 12 is PW1, 3 by 12. Now the second ball without replacement has to come as black. How many blacks are there? So this is the second ball of the first case. W1 or white ball has already been picked up. So now only 11 are remaining For the second drawing, 11 will remain. Next has to be black. We assume that the white has already come, but still there are 5 blacks in here. So this 5 is what we are going to use here. So 5 by 11 here. The next one. First case is done. Now we are talking about B1, W2. Black one followed by a white one. Now 12 in all are there in the first picking. First ball is to be black. So 5 black is already there. So 5 by 12 is the probability of getting the first black ball. So just write it here. Now when we pick up the second ball, already one ball which is a black ball has been taken out. So 11 is remaining. Next it has to come as W, which is white ball. And there are 3 white balls. So this 3 by 11 will come. So if you see, the numerator and denominator are similar. So you can just twice it. The final result will be 5 by 22. Now this is how we are going to write about it. If you want to add more reasoning and logic, you can use what I have suggested. A bag contains 8 red and 6 green balls. 3 balls are drawn one after another without replacement. So there is no replacement. Find the probability that at least 2 balls drawn are green. Now this is a tricky question. Most of us will think that the 3 balls are coming. At least 2 balls are drawn are green. That means what? I'll give you a hint. But the reasoning of this question will be, we are going to find out at most. See, you can subtract it for something. So when we subtract, the probability of at most 1 ball. There are 3 balls. If at most 1 green ball is subtracted from 1, we'll get at least 2 balls are green. I hope you got the logic. So what are all the possibilities? So we have a bag here, and in this bag we have 8 red balls and 6 green balls. First ball is picked up, then second, then third, and there is no replacement. So first green, because we are talking about at most 1 green ball. Either first can come green, either second can come green, or third can come green. This is what we are talking about. At most 1 green ball. So first green, second green, and third green. These are the possibilities. And there is also one possibility. There is no green as well, since all of them can come as red. 3 balls are there. First green means what? First G, then R, then R. So let's call it as 1, 2, 3. So G1 is green first, then red and red. The second case, green has to come in the second place. Third green, the green should come in the third place. And no green means all of them should be green. R1, R2, R3. Now we have to compute the probability of this one. And then we'll subtract it with 1 so that we get P at least, probability of at least 2 balls are green coming. So 1 minus probability of, this is probability of first green. We add all the probabilities, that is the first green, the second green, the third green, and no green. We are adding it and then we are subtracting it from 1 in order to get the required result sought by this question. So 1 minus probability of first green. So this G1, R2, R3. G1, that is green, should come first. In all, how many are there? 8 plus 6 is 14. So we have 14 balls now. 1 green has to be drawn. There are 6 greens available. Now next has to be a red ball. And only 13 is remaining because 1 has been picked up. So green has been picked up. The second needs to be a red. 8 reds are there, so 8 by 13. Now one more ball which is red is taken out. In 13, 1 is also picked up, so only 12 is remaining. But in 8, 1 is already been picked up because we need the third as red. So it will be 7 by 12. So 6 by 14, 8 by 13, 7 by 12. All options will give you this only. You will just see. This will come as 336 by 2184. If you multiply this. The next one, first should be red. So 14 are there. How many reds are there? 8 reds are there. So 8 by 14 is the probability of getting first as red. Next one should be green. 1 ball is already taken, so only 13 are remaining. Second ball has to be green. How many greens are there? 6 greens are there. Now the third one, third picking has to be the red. 2 balls are already gone. So 14 minus 2 is now 12. And in the red, first red is already being picked up. The second red, which is the third red here, is only 7 because 1 red is already picked up. So this will again come as the same number, 336 by 2184. You know already is numerator has 6, 8, 7. Denominator has 14, 13 and 12. Now coming to the first red, second red and third green. So 14 are total. First red is 8. Second is red. That is 1 is being picked up. So 13 is remaining. 1 red is also been picked up, so 8 minus 1 is 7. So 7 by 13 will come. Now talking about green, because 2 balls are already been picked up, so 12 is remaining. Green, all are available, 6 are there, so 6 by 12 will come. So all the time this 6 into 7 into 8 will come in the numerator, and 12 into 13 into 14 will come in the denominator. It will be 336 by 2184 again. Now no green, that is all has to be red. R1, R2, R3. So let me write it here. There is a less space, so I am writing it here on the left corner. So 14 are there, first is red, so 8 are available. Second time 1 is being picked up, that 2 are red, so 13 are remaining. 8 minus 1 is being picked up, so 7 is remaining only, so 7 by 13. Now 2 reds are being taken up, only 6 is remaining for us, and in total 14 minus 2, which is 12. So this will again come as 336 by 2184. So all in all, when we compute this is going to come as 1344 by 2184. You subtract it with 1, 5 by 13 is going to come. So this was a good question. It is being done, or it has to be done like this. Okay, this is how you are going to write. Now at least 2 balls. That means you can say, because the possibilities are too many, at least 2 balls means exactly 2 is what? Green, green, red. This is just the possibility of getting 2 greens. So GGR, GRG, RGG. So 2 greens are there. At least 2 balls of green means it can be 3 greens also. So these are possibilities you can perform. But this is the better way. Arun and Tarun appeared for an interview for 2 vacancies. So there are 2 persons, and the probability of Arun's selection is 1 by 4, and that to Tarun's rejection is 2 by 3. Find the probability that at least one of them will be selected. So what all is given in the question, let's write that. So this probability, the first thing is Arun is selected, I'm writing it in short, is equal to PA. I'm calling Arun as A, Tarun as B. So the selection is 1 by 4 here, and the Tarun's rejection is given. Tarun's selection is not given, it's rejection. So we are talking about Tarun's rejection. So I'm writing Tarun's rejection in short. Tarun's rejected. Arun selected. So let's call it PB bar. See, positive things we take as A, the against thing we take as bar or complement. So P of Tarun selected is PB. That will be, the selection plus rejection of one person will be adding up to 1. This will be 1 minus 2 by 3. This is 1 by 3. Rejection of PA will be, well, this will not be used in this question, but the probability of Arun being rejected can be computed like this. If at all it has to be used, 1 minus 1 by 4, that is going to be 3 by 4. Now probability that at least one of them will be selected, at least one of them will get selected. So this is PA union B. This will be PA plus PB. At least one of them will be either A or B or both of them. So PA plus PB minus PA intersection B. PA intersection B, because of the independency, we can write it as PA multiplied by PB. This comes out to be 1 by 4 plus 1 by 3. PA into PB, that is 1 by 4 multiplied by 1 by 3. So this 3 by 4 is not required. We computed it, but it isn't used. So the final result is 1 by 2. Now this is how you need to do this. And please remember, the selection and rejection are 2 different things. So this one is a good question. We must talk about it in detail because there are questions coming in the later part of this exercise where this kind of question will be used. First is what is geometric progression. The geometric progression is something like this, where we have a common ratio. Every consecutive content or the element of a series will have the same ratio. That is, a square by a is a by 1 is a cube by a square is a. I have written a, but it is actually a cube by a square. So just correct it. So the consecutive, any 2 you take, the ratio will be common. So when you add these series till infinity, it will be 1 by 1 minus a. A is the first element after 1, or you can call it as a common ratio as well. So A and B toss a coin. It's alternative. If A starts the game, find the probability that B will win the game. So for B to win the game, B has to have a head, A has to fail, so A has to have a tail. B head, A tail. But there are multiple ways in which B can win. So let me explain you how we are talking about this. So a coin can give you head and tail. So head probability is 1 by 2 and tail appearing probability is 1 by 2. Now when A starts, what will happen? Because it's being given clearly that A is going to start the game, but B has to win. That means A has to fail. So A first is half, because tail probability of A is half. The probability of B passing is again half, because head is half. Now B has won. The first A fails and B wins. A tails, B head. Now second time what can happen? A tail, B tail. A tail, then B head. Then B will win. All three options should be tail. So half, half, half. That is the A, B, A, then B. B is winning here. Now there is a third case and it goes on and on. So it will be 6 times now. So 5 tails followed by a 1 head. So tail, tail, A, B tail, then again A, B tail, then again A tail, then B head. But here head and tail probability both are half. But in order to get another questions where it can be different, this half is all about head and tails. So first one is half into half, that can be written as half square. The second one is half into half into half into half, that is 1 by 2 raised power 4. Then 1 by 2 raised power 6. 1 by 2 raised 8, like that. Power 10, power 12, like this it will go on and on. So you can take this 1 by 2 whole square, which is going to be 1 by 4 as outside, as common you can say. The inside will be a geometric series, a geometric progression. So 1 half square, half raised 4, half raised 6. So this inside material or a content, when you divide them, you see this A is representing 1 by 4 here, which I initiated the GP. So it's representing A only. So 1 plus 1 by 4 plus 1 by 2 to the 4, 4 to the 8. 2 to 2 raised 4 is 2 to the power 4. That is 2 4 times. That will give you 16. 2 raised 6 is, it's 2 multiplied 6 times. That will give you 1 by 64. So now 1 by 16, if you divide any one of this, 1 by 16 divided by 1 by 4, 1 by 64 divided by 1 by 16, any of you divide, you are always going to get 1 by 4 as the A. 1 by 4 remains as it is, which was the coefficient. We have taken it outside earlier. And this is 1 by 1 minus A. A is what? 1 by 4. So 1 minus 1 by 4 this is. So this will give you 1 minus 1 by 4 is 3 by 4. It goes into denominator. This goes up, 4 gets cancelled, and you'll get 1 by 3 as the result. I hope you got the concept. So this geometric progression will be used in the later part also. So this is how you are going to write it whenever you are writing it. 2 cards are drawn from a well-shuffled pack of 52 cards, one after another without replacement. There is no replacement. One has been taken out, it has been taken out. We are not putting it back. Find the probability that one of these is a red card and the other is a black card. So there are in all 52 cards. When we pick the first card, it can be a red card and then it can be a black card. They are not precisely saying that red has to be the first card or black has to be the second card. So red can be the first card, black can be the second card, and vice versa. Black can be the first card, red can be the second card. So this is how we intersect. So the probability, when you add these, this is your answer. So what we are trying to suggest here is that probability of a red and a black card, that is one red and one black card, is going to be equal to probability of getting a red card followed by a black card. The first is a red card. This is what it represents. PR intersection B. The first red and followed by the second black card, and this is when the replacement is not done, without replacement. The second case KB can be first card coming out to be a black followed by the second card which is coming as red. It appears as a red. This is the probability of B intersection R, which I am representing on the right hand side, which you see also. Now PR intersection B, now you can directly write PR intersection B for this case, and B intersection R for this case. R comes first, black comes second, then black comes first and the red comes second. Now these are independent events, so multiply them. PR multiplied by PB plus PB multiplied by PR. You know already what independency means now. Now the probability has to be computed. This is just the explanation. Our all idea is to compute the values. So there are 52 cards. First red is coming. There are 26 reds and 26 black in a well shuffled 52 cards deck. So first is 26 divided by 52 because the red are 56. 52 are total. Now second case, because one has already been taken out, so 51 will remain, but there are still black 26 cards, so 26 by 51. That is why I am writing 26 by 52 for the first red card, and the second black card is 26 by 51. For the second case, black, again there are 26 black, 26 by 52, 51 are remaining now. Now still there are red 26 cards, so 26 will remain as it is. We're not picking up anything from the red card for the second case. This is 26 by 51. Answer will be this one. So this was a good question, but if you want to give more explanation, whatever I have provided, you can do that. Tickets are numbered 1 to 10. 2 tickets are being drawn. Find the probability that the number on one of the tickets is a multiple of 5 and the other a multiple of 4. So it's better always, I always suggest that you write these numbers. So when the sample space is written clearly, the other sets can be easily formed. So the curly braces should be put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all the tickets which are numbered 1 to 10. I apologize for these square brackets. It has to be curly brackets and all the elements has to be separated by a comma. Now probability of a ticket being multiple of 5. I'm just writing M5 for representation. So there are 10 elements in this set and 5 and 10 are the multiple of 5. So 2 by 10 favorable cases divided by total number of cases. The probability of M4 multiple of 4. How many total numbers are there? There are 10 and favorable are 4 and 8. To 2 by 10. So one of the tickets is a multiple of 5 and the other is a multiple of 4. That is, you need to have an intersection between this PM5 and PM4. But is it being given which has to come first and which has to come second? We'll just see. So the first can be a multiple of 5, second can be a multiple of 4 and vice versa. That's what I have written just now. So I'm just writing M5 and M4 for representation, and now you know that I'm writing it for the multiple of 5 and multiple of 4 respectively. So M5 and M4 probability of getting these two, and this two can be achieved in two ways. First you get the ticket which is a multiple of 5 and then you get a ticket which is a multiple of 4, or you get the first as a multiple of 4 followed by the ticket which is the number 5 multiple. So we can write it as a PM5 multiplied by PM4 because these two are independent events. So and means intersection here. Similarly here also. So we have PM4 multiplied by PM5. So this will be 2 multiplied by PM5 PM4 because they are exactly the same. So you can just write like this. Now I'm just writing something. Alright, whether it's correct or not, you have to tell me. 2 multiplied by PM5, which is 2 by 10. You know, normal naive person who is just doing the question will do like this. PM5 is 2 by 10 and PM4 is what? 2 by 10. So just multiply this. Are you going to get the answer? Are you going to get the answer? So one after the other at random. So the question is not providing us the important information whether it is done with replacement or without replacement. So if it is with replacement, this is what is the correct version. So we are not replacing it. We are replacing it, sorry. So 2 by 25 is with replacement. But I am just calling it incorrect because this exercise is mostly about without replacement. So when it is without replacement, then what we are going to do? Same thing, but with just reduction of the ticket numbers. Like 2 by 10 is the probability of getting multiple of 5. But when we have taken out 1 already, only 9 are remaining for this second ticket being drawn. So when ticket is being drawn, there are still 2 numbers which are multiple of 4. Similarly, in the second case, 2 by 10, 2 numbers have to be drawn and these are the multiple of 4, 2 by 10. But 1 ticket has been drawn, so 1 has to be deducted from 10. So 9 and 2 still remains as a multiple of 5. So when you compute this, this is going to be, it will be 2 into 4 by 90, that is going to be 8 by 90. 8 by 90 is the result we are talking about. You can write it as 4 by 45. So we are assuming it to be the replacement not done. So this is how this will be done. And now a family tells a lie. 30% cases husband says a lie. So husband H 30%. So husband lie is 0.3. 30 by 100. 30% is 30 by 100, which comes out to be 0.3. Now wife also telling a lie, or while wife telling a lie. No, not also, but wife telling a lie is 35%. 35 by 100, that is going to be 0.35. So wife telling a lie becomes 0.35. Both contradict each other. That means the husband, we are talking or we are calling representing husband as H. So probability of husband, actually it's other way around. We always take the positive thing as H, the negative thing as H bar. So probability of, so I'm just changing this. It's lie, that is why I'm representing it by H complement or H bar. and telling a lie, telling a truth is PH. Similarly, telling a lie for a wife is PW bar, and probability that the wife speaks the truth is going to be PW, which I'm writing it as 0.35, which comes out to be 1 minus 0.35, and that comes out to be 0.65. Now, probability that both wife and husband contradicts. That means if one say truth, the other has to speak a lie, and vice versa. So probability that husband is saying a truth and wife is lying, or in the second case, husband is lying, the wife is speaking the truth. Since these are independent events, we can write it as PH multiplied by PW bar, and this PH bar multiplied by PW bar. So it's not intersection in the second case. Please correct it with multiplication. There is a slight incorrection I have done. 0.3 into 0.35, PH bar and PW also we have computed. So we will write the numbers which are 0.3 multiplied by PW is 0.65. And we compute these two, we are going to get 0.44, writing it in the percentage terms is 44%. So this is how you are going to go about it, and I hope that this can be done by you. It's quite easy now. Husband and wife appear in an interview for two vacancies for the same post. Same post, one post, two vacancies, husband and wife. So two people for one vacancy. One person is a husband, the other one is the wife. The probability of husband selection is 1 by 7. So probability of husband being selected, we call it as H. So probability of H is 1 by 7 being given in the question. Probability of wife being selected, PW we are referencing, it's 1 by 5. So what is the probability of both of them will be selected? Both of them means what? Husband and wife both together. So H intersection W we are talking about. So the probability we are trying to find out is, let's write it in the words, husband selected here, wife selected here, husband and wife selected here. You have to write it here. I'll show you how to write that. So this is equal to, because these are independent events, this will be PH multiplied by PW, and since the probability is already given, just multiply 1 by 7 with 1 by 5, and this gives you 1 by 7 5 is 35. So this is how this will be done. So husband will be selected is the first one. Second one, wife will be selected. So we are calling it as H. I called it this as W, and both will be selected means intersection will be taken, and the independency of the event makes it just multiply two probabilities of being selected. So we are doing the same scenario because it is 14.1, 14.2, 14.3. Three parts are there. So what is the probability that only one of them will be selected? So needs to be select only one. So let me write the probability of husband being selected and the wife being selected one more time. So PH is 1 by 7, PW is 1 by 5. Only one of them will be selected. That is, either husband gets selected or wife gets selected, but not both. So husband, wife should not be selected. When husband is not selected, wife should be selected. So this is the scenario we have to solve here. So H intersection W bar and H bar intersection W, these two different probabilities have to be added. So probability of only one of them will be selected, that is one of husband or wife will be selected. This equals probability of husband being selected and wife is not being selected, and or probability of husband being not selected and wife getting selected. So these are independent events. Let's do this PH multiplied by PW bar for the first one, and for the second one PH bar multiplied by PW. So what is PH here? 1 by 7, 1 by 5 is PW. So let's find out PH bar, which is probability of husband not getting selected. So 1 minus 1 by 7 will be there. This becomes 6 by 7. And PW bar is simply subtract 1 by 5 from 1. So 1 minus 1 by 5. This is the first one, PH bar. Let me write it as 6 by 7. And now here 1 minus 1 by 5 is 4 by 5. So let's write it here. PH is 1 by 7. Let's write this one. PW is 1 by 5. PW bar is 4 by 5. And PH bar is 6 by 7. So what do you get out of it? It's basically 10 divided by 35. So 2 by 7. So this is, you have to write it again, and then only one of them will be selected, will be computed in this scenario. Now the same scenario, as I said, the background is same. Now we have to find the probability that none of them will be selected. This means neither H nor W. H bar intersection B bar, or H complement intersection W complement. This is the simplest thing which is to be done in this question. So probability of getting H being selected, probability of W being selected, and when they are not selected, it's simply H bar and W bar. So we can write them as the separate events because they are independent. PH bar multiplied by PW bar. PH bar is, we have computed it already. 1 minus 1 by 7 was there. So this is going to be 6 by 7. And PW bar is 1 minus 1 by 5, which was 4 by 5. So 4 by 5 multiplied by 6 by 7 will be the result. So when you multiply this, you can get this as again 24 by 35. That's your answer. So this is how you're going to go about it. Please remember, none of them will means first knot, second knot, both intersection. It's complement. A bag contains 7 white, 5 black and 7 red balls. So let me make a bag just to represent it diagrammatically. 7 whites, 5 black and 4 red balls. 4 balls are drawn without replacement. Find the probability that at least 3 balls are black. So what does it mean? At least 3 balls are black means we need 3 blacks because there are 4 being drawn. So either 3 balls are black along with some other color. It can be white, it can be red. So let's assume that the 3 are black. The first one comes out to be, it can be a white or it can be a red, and that these can come in any order, at least 3. Now 4 black color can also come, at least means 4 also can come, 4 black can come. So 4 black balls. So it can be black, 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 or all of them can be or should be black. Now this first one can be white or red, the other can be the other three can be the black balls, or you can have first black, second white or red, then black, black, or first black, second black, then white and red, and then black, or first black, second black, third black, and the fourth one any of white or red. So these are the 4 different probabilities. You have to just multiply and add. This you can do, but you can do from the observation or the experience we have. We know that all these 4 are going to come same. So just find one probability, multiply it by 4. So what we are suggesting here is probability at least 3 black balls is equal to probability of exactly 3 balls which are black. So exactly 3 black balls. The other one, which is the leftover, that is the 4th one, can be any of it, white or red. And probability of all 4 blacks has to be added. These are the 2 possibilities that needs to be added. Now just take any of these multiplied by 4 because the probability is going to come same. Even if you try doing this W, B, B, B plus B, W, B, B, like all these probabilities, if you compute, then multiply and then add all of them. So all of them in these 16 total balls, 11 are the white and red. So the probability of getting a white and red is 11 by 16. Now then next 3 has to be black, but 1 is already been drawn because it is without replacement. So black is how many? There are 5 blacks. So 5 by 15. Now 2 are taken from 16, so 14 are remaining. 1 is taken from black, so 4 are remaining. Now 3 balls are being drawn, so 13 are remaining. 2 out of 5 black balls have been taken, so 3 divided by 13. Now this is 1, 2, 3, 4. And since these arrangements can be done in 4P1, now you tell me it should be 4C1 or 4P1. That's a question for you. So that will come as 4. I hope you got the idea. Just compute one of these and multiply it by 4. Or if you want to give more explanation, just take one, say compute 1, compute 2, compute 3, compute 4 separately and add them. This is going to come 4 times only. Now 5 by 16 is the first black ball because 5 are black balls, 16 are there. Then 1 is being taken, 4 by 15. 1 is being taken. 2 is being taken, 2 are being taken, so 3 by 14. 1 more is being taken, so 2 by 13. So this black is quite easy because there are only 4 blacks. The first part, which is the exactly 3 black, you need to just understand that thing. So when you compute this computation, I hope you'll be able to do that, and that is going to come as 23 divided by 364. So this was a good question. This 4 multiplied is simply this WR black, black, black. W oblique R is either W or red can come. Similarly, what you can do is you can just compute individual probability, multiply them. This is just for one case. Then you again multiply the probability of B1, WR2, B3 and B4. That is separate probability needs to be multiplied. And then all these 4 probabilities which are going to come are to be added. That is, the third one will be the black, black, white or red, and then black. So these all 4 have to be multiplied, means the row which you are seeing, all these rows needs to be multiplied and the columns needs to be added. So these are different probabilities that are going to come. And the better thing is just to compute one probability multiplied by 4, because eventually the result will be same. So I took a shortcut. You can take a shortcut or a long cut. A, B, C are independent witnesses of an event which is known to have occurred. These are independent witnesses. A speaks the truth 3 times out of 4. B 4 times out of 5. C 5 times out of 6. What is the probability that the occurrence will be reported truthfully by majority of 3 witnesses? So probability of A telling the truth is 3 out of 4, 3 by 4. Probability of A not speaking the truth or uttering a false is 1 minus 3 by 4, which is going to come as 1 by 4. Now probability of B saying the truth, 4 out of 5. So 4 divided by 5 is PB. How about PB bar? That is B not saying the truth. This will be 1 minus 4 by 5, 1 by 5. Coming to the C. C probability is 5 times out of 6. So 5 divided by 6 it will be. And C not speaking the truth is 1 minus 5 by 6. 1 minus 5 by 6 is what? It's going to be 1 by 6. So what is the probability that the occurrence will be reported truthfully by a majority of 3 witnesses? So there are 3 of them, A, B and C. So in these 3, majority means either A or B says the truth, C doesn't, or A or C says the truth, B doesn't, or A does not speak the truth, B and C say the truth. A lies, B and C say the truth. Now majority means what? These are 3 cases which we understood. But one more thing is all of them are saying truth. Let all of them say the truth. When they say the truth, this is also majority. Majority is basically 2 out of 3. So even if 2 of them say truth, this is majority. But if all of them are saying truth, this is also majority. So this is we have to write in the form of probability. The probability of majority speaks truth, or majority of the 3 witnesses speaking the truth, you can write whole of it or in the short also. This will be probability of 2 speaks truth, 2 are speaking truth at a time and 1 is denying, or all of them are speaking the truth. So this is going to be equal to this, all whatever I have written, I am just writing it here. PA intersection B intersection C bar plus PA intersection B bar intersection C, then probability of A naught, that is A naught speaking the truth, B and C are saying the truth. And finally, all of them are saying the truth. So PA intersection B intersection C. Now this can be separated. It's PA multiplied by PB multiplied by PC bar. And if you remember or recall, we have already computed all these values when we started this question. This is going to be the second part is PA multiplied by PB bar multiplied by PC. The third term is PA bar, because these are independent events. So PA bar into PB multiplied by PC. The final one will be PA multiplied by PB and multiplied by PC. Now all these probabilities are being computed already. Just replace the values here and you'll find the result. So PA is 3 by 4, PB is 4 by 5, PC bar is 1 by 6. PA is 3 by 4, PB bar is 1 by 5 and PC is 5 by 6. Now PA bar is 1 by 4, PB and PC are 4 by 5 and 5 by 6 respectively. And PA into PB into PC, it is already given in the question, 3 by 4 multiplied by 4 by 5 multiplied by 5 by 6. So just write it here. These 3 values are being multiplied. And when you compute these, concept is important. The computation I hope you'll be able to do. The final value is going to be 107 divided by 120. Alright, these are the final value, which is the all of them speaking the truth. So this was again a good question, and this is how it needs to be done. A bag contains 4 white balls and 2 black balls. There is another bag, 3 white balls and 5 black balls. If one ball is drawn from each bag, find the probability that both are white, both are black, and one is white and one is black. So let's make the diagrams so that you can understand better. These are 2 different bags. The first bag has 4 white, second bag has 3 whites. The first bag has 2 black balls, the second bag has 5 black balls. So in all, 4 plus 2, 6 balls, white and black in the first bag, and the second bag has 5 plus 3, that is 8 total balls. if one ball is drawn from each bag. So one ball each is drawn from both the bags. Both are whites. Now the first probability will be when we tend to find out both are going to be white. This both are white. So the first picking should be white. Second picking also should be white. Probability, let's call them as W and B. It will be better. And we can regard this W1 from the first bag, W2 from the second bag. So this is the representation we are going to follow. The probability of W1 intersection W2. This is W2. And this is equal to PW1 multiplied by PW2 because they are separate events, independent events. Now what is the probability of getting white? The totals are 6 and 8 respectively. First bag 6 total, second bag 8 total. That will come in the denominator. You already know that. So favorable cases, how many whites are there? 4 in the first bag, 3 whites in the second bag. So this will be 4 to the 8, 3 to the 6. This is going to be 1 by 4. Now coming to the second one, both are black. Same thing here. Both are white, both are black. The concept remains the same. Only the probability values will change. So this B1 coming from the first bag and B2 which is coming from the second bag. So B1 intersection B2 probability we need to compute. Now this probability B1 intersection B2 can be written as probability of B1 multiplied by probability of B2. This is why, because they are certainly the independent events. Now the denominator remains the same. It will never change because in this question the total numbers are 6 and total number are 8. How many blacks are there in first? 2. How many blacks in second? 5. So 2 by 6 multiplied by 5 by 6, and when you multiply these two, 2 3s are 6, 5 by 8. There is a multiplication sign in between, okay? Please remember that. I forgot to put it. It is 5 by 24. Now the third one. One will be white and one will be black. So there are two possibilities. White from the first bag, black from the second bag, or vice versa. That is black from the first bag and white from the second bag. You can call it as W1 and W1 and B2 plus B1 and W2. This is probability. One is white and one is black means first white and one black, second black, that is. So if white is coming from one, the black should come from another. W1 intersection B2 it will be. But there is also one more probability that the black can come from the first one and white can come from the second one, and is always intersection or is always the union. So W1 and B2 or B1 and W2. So probability of getting the black as the first ball and white as the second ball. So B1 intersection W2. This is going to be the second possibility. Now these are independent probabilities. So we can write PW1 multiplied by PB2 in first case plus probability of B1 multiplied by probability of W2. So probability of W1 will be what? Wherever you have 1 1, first put the denominator as 6. It will be better. Wherever you have this 2 2, B2 and W2, then you put the denominator or keep the denominator as 8. Now what is W1? 4 can come, 1 out of 4 can be taken. B2, how many blacks are there? 5. So 1 can be taken from 5. How many blacks in the first one? 2. How many whites are there in the second one? 3. So when you compute this, so this will be 13 by 24 when you compute this. So formally, if you want to see how it can be done or it will be done, so this is how it will be done. So this is how it needs to be written, because all this written thing is key. A bag contains 4 white, 7 black and 5 red balls. 4 balls are drawn with a replacement. What is the probability that at least 2 are white? At least 2 are white. Wherever you have at least, normally the question will be subtracting something from 1. So you have a bag here. In this bag there are 3 types of balls. 4 white balls, 7 black balls and 5 red balls. So in all, how many are there? These are 16 in all balls. Total are 16. 4 balls are drawn with replacement. At least 2 of them should be white. At least 2 whites, 3 whites, 4 whites. Alright, let me make 4 balls and then tell you that 1 white it can be. At least 2 white means the maximum, the possibilities is all the 4 balls, 3 balls, 2 balls, 1 white balls. But we are interested in only at least 2 white balls. So you need to fix 2 white balls, first case. Then you have to fix 3 white balls. Then you have to fix all the 4 white balls. So this W1, W2, W3, see, all these possibilities can be done. The better way is not to follow this approach, but better is that no whites or 1 white. And when you subtract this from 1, you will get at least 2 are white. So it will be an easier way or approach to solve this question. So this probability of at least 2 white balls, this comes out to be 1 minus probability of maximum 1 white. More than 1 white cannot come in the first case. So there will be no white ball also. There is also one possibility. See, maximum 1 white ball means no white ball plus exactly 1 white ball. So this probability of maximum 1 white ball can again be divided into 2 parts. So let me write it here. This maximum of 1 white ball means probability of no white balls plus probability of exactly 1 white ball. I hope you are getting the concept. So 1 minus no white means there is no white coming. So from where the other balls can come? It can be a black ball or it can be a red ball. In all, 7 plus 5 is 12. So 12 is the favorable cases. Total numbers are 16 cases. Replacement is there. Again 12 by 16. Then again 12 by. The third ball also can be from 7 and 5 black and red balls. So 12 by 16 4 times. Because there are 4 balls with replacement. Or, now this is the first thing, exactly 1 white ball. So in these 4 white balls, when we are drawing one by one, any white can come. But one white has to be there. So this can be white, first can be white, the second can be white, the third can be white, or the fourth can be white. But all others, all the 3 others can be a black ball or a red ball. So B oblique R represent either a black ball or a red ball that counts to 12 balls. White ball counts to 4 balls. Total ball counts to 16 balls. So these are the 4 possibilities here. So we'll just compute one of them and multiply this by 4 because there are 3 possibilities or 3 arrangements, you can say. 3 arrangements. 4 arrangements, sorry. 1, 2, 3, 4. There are 4 rows I draw. 4 balls. Now how many whites are there? 4 whites. Total are 16 balls. The probability of getting a white is 4 by 16. Now again replacement is going on, so 16 I am writing in the denominator. Now all the other 3 which are coming from either black or red balls, and in all there are 12 red and black balls. Black and red, how many are there? 12. 12 by 16, 12 by 16, 12 by 16 because replacement is happening. But there is one more thing. I just told you that there are 4 arrangements here. White can be the first ball, second ball, third ball, fourth ball. So these are 4 combinations, or you can say 4 arrangements to be precise. So multiply it by 4. So these are the permutations which we are interested in. So this is 1 minus T1 by 25, 256, sorry. And this is going to be the second part is going to be 108 divided by 256. When you compute the total, this will be 67 divided by 256. Computation you can easily do, concept you understood. So this is how it needs to be done. Let me tell you again, at least 2, this also can be computed, it's not a problem. But 1 minus probability of maximum 1 white ball, which includes no white and exactly 1 white ball, is a good way or good approach to solve this kind of question. 3 cards are drawn with a placement from a well shuffled pack of 52 cards. Find the probability that the cards are a king, a queen and a jack. So there are 52 cards. There are 4 queens, 4 king and 4 jack. There are 4 suites, and in all these suites we have 1, 1, 1, 1, Q, K and J respectively. So in all these we have 52 as the denominator. Why? Because 52 in all cards are there, and this is done with replacement. Always the total number of cases are 52. So probability of king, queen and jack we are going to compute separately. What is king? 4. How many queen? 4. How many jacks? 4. So this is nothing but 1 by 13. 4 by 52 is 1 by 13. Now probability of getting these 3, so it will be king intersection Q intersection jack. But I told you QKJ in the first case when I was explaining. Now I have written KQJ. So that is how the arrangement factor will come. So these are independent events. So PK multiplied by PQ multiplied by PJ can be written. What is PK? 4 by 52, which is 1 by 13. What is PQ? 4 by 52, which is again 1 by 13. And PJ again 4 by 52, which is 1 by 13 only. Now the answer hasn't come because either of or all of these 3 can take any place. So these are 3 positions. The K, Q, J can come. The Q, K, J can come. Or in this way, there are multiple things which can come. Multiple arrangements can be there. So there are 6 combinations in all. Now your question will be from where this 6 has come. There are 3 elements and this needs to be arranged in 3 places. So this is permutation. 3P3 is the permutation. Whenever we arrange its permutation, whenever we select its combination. 3C3 we are not talking about. We are talking about the arrangements only. Now what is NPR? NPR is factorial N factorial n minus r. So this is factorial 3 divided by factorial 3 minus 3. This becomes factorial 3 divided by factorial 0. Factorial 0 is 1. So factorial 3, which is going to be 3 into 2 into 1, which is 6 only. That's how 6 has come up. Let me write it also so that it gets into your mind easily. So 1 by 13 3 times, that is 3 by 13 multiplied by 6 will be our final result. So 6 by 2197 is the final result. So this is how this will be done. I hope you are getting this factorial 3 why it has come. A bag contains 4 red and 5 black balls. A second bag contains 3 red and 7 black balls. Now one ball is drawn at random from each bag. Find the probability that the balls are of different colors and balls are of the same color. So it's better to understand the question with the diagram. So we have 2 bags here. The first bag contains 4 red and 5 black balls. So in all there are 9 balls in the first bag. Coming to the second bag. So let's name them as 1 and 2. Second has 3 red and 7 black balls. So in all there are 10 red balls in the second bag. So let me write it here, 10 balls in all. So the first one is balls are of different color. What does it mean? 2 balls are being picked up. So we will write the probability like this, ball of different colors. A ball are of different colors. So this is only possible when you get a red from one and black from second, or vice versa. That is black from one and red from another. So we'll write it as R1, B2. R1 represent red from one, B2 represent black from two. Then B1, R2. B1 represents black from first and red from second. R2 represent that. So this is how it's going to be written in the probability. Then we'll transform this probability into actual values. So the first one will be probability of getting a red from the first bag and black from the second bag. This is the first one I have written. The second one I'm writing as the black from the first one and the red from the second one. So here's the bracket after black one. You can ignore that. So I'm going to write this as P, this R1 or B, R1 and B2 and B1 and R2, and then we have to OR them. So R1 intersection B2 is the probability of the first one. Then the probability of B1 intersection R2. So these two, because these are independent event, we can write it as PR1 multiplied by PB2, and then this one also PB1 multiplied by PR2. Now the actual values. Wherever you get R1 or B1, wherever 1 is there, first bag, the total number of balls are what? 9. That goes into the denominator, you already know. So just write the denominator here. How about the second one? That is the second ball. In all, there are 10 balls. So 10 balls come in the denominator wherever B2, R2 comes. Now coming to the favorable cases. What are the number of red balls in the first one? 4. Black balls in the second one? 7. Black balls in the first one? 5. Red ball in the second one? 3. Now add them. So you get 43 by 90 in all. Now the second option or second option in the question. Balls are of the same color. So we'll write like this, probability of same colors. This means the probability will be both should be red or both should be black. There are 2 different colors. So balls of the same colors means getting red from first and second and getting black from first and second. So R1, R2, red from 1, red from 2, B1, B2, black from 1 and black from 2. This will be both red means R1 intersection R2 and both black means B1 intersection B2. So if you write them separately because they are independent events, PR1 multiplied by PR2 first case and second case PB1 multiplied by PB2. Now wherever you have R1, that is the first bag, write 9 in the denominator, B1 write 9 in the denominator. Wherever you have the bag 2, write 10 in the denominator, here also 10 in the denominator, multiply them and add them. Now what is the probability of R from the first one? 4. There are 4 red. What is R from the second one? How many reds are there? 3. So 3 by 10. How many black from the first one? 5 blacks are there. So 5 by 9. How many blacks from the second one? 7. So this is 7. When you multiply them, the final result will be 47 by 90. These are the 2 probabilities of this question. And this is how it will be done. This is the formal way of writing. If you ever have to write it like this. A can hit a target 3 times in 6 shots. So let's write the probability now here. So we'll read the question, but as it comes, A can hit target 3 times in 6 shots. So probability of A hitting the target is 3 out of 6. That is, in all 6, which is the total number of cases, 3 are the favorable cases. So 3 divided by 6 is 1 by 2. The probability of B hitting the target. So when B hits the target, what does it mean? So B hits target means 2 times in 6 shot. 2 are the favorable cases, 6 are the in all cases, total cases. So 2 by 6. This becomes 1 by 3. Third one is probability of C hits the target. When C hits the target, the probability is 1. This will play a very important role in when we are solving the numbers, when we'll get the numbers, right? First, we have to devise the formula and expression, etc. So probability of C hitting is always 1. Now these fix a volley. What is the probability that at least 2 shots hit? That is minimum 2 has to shit. 2 has shots have to be hit. So this probability of at least 2 shot hit. So 2 shot hit means what? It means it has to be at least 2 shot, or it can be 3 shots. It cannot be 0 shot. It cannot be 1 shot or one of them hits the shot. It has to be either 2 of them hits the shot or all of them hits the shot. This means we'll take 2 separate probabilities and we'll add them in order to get the at least 2 shot hit. So probability of exactly 2 shots hit, and along with this, the probability of all the 3 should hit. Exactly 2 shot hit is the one probability. We have to add it with all the 3 shots are being hit to get the probability of at least 2 shot are being hit. So 2 probabilities. 2 means A hits, B hits, and C does not hit. See, this C naught will eventually come to 0 only. But A hits, B does not hit, and C hits. Now A doesn't hit, B and C both hits. Again, in these all 3, which the terms you are actually witnessing, all these 3 are for exactly 2 shots being hit. The probability of C not happening is not valid here. Why? Let me compute the probability of not hitting. So A bar will be, A complement will be 1 minus 1 by 2. That is, A does not hit. B does not hit is 1 minus 1 by 3. That is 2 by 3. C doesn't hit. That means 1 minus 1, which is going to be 0. So that is why the first one I crossed it. But better is to keep it. I will urge you to keep it. A hits, B hits, C doesn't hit. So these 3 are for P probability of exactly 2 shots being hit. AB is happening, AC is happening, BC is happening. Now all the 3 this shot is happening is A, B, C. All are happening. So PA intersection B intersection C complement, PA intersection B complement intersection C. That will be our second term while we write the probability. So A, B, C naught, A, B naught, C, and third is coming up, which is A naught, B, and C. Then the third one, actually the fourth one, which is all the 3 shots, PA intersection B intersection C. Now, since these are independent terms, we can write it as PA into PB into PC bar, or PC complement, PA into PB bar into PC. This is the second one. The third one is PA naught or A bar, PB, and multiplied by PC. Now the final one will be all those hits, PA into PB into PC. All of them hit together. Now let me write the values. The space is less for us, but still we'll complete it. PA is 1 by 2, PB is 1 by 3, PC naught is 0. That's why I was, trying to cross that, but I would keep it. PA is 1 by 2, PB naught is 2 by 3, PC will be 1. Here PA naught is 1 by 2, PB is 1 by 3, and PC is 1. Now PA into PB into PC, all these 3, 1 by 2 into 1 by 3 multiplied by 1. When you compute all of these, you'll get 2 by 3. So this is how this will be done. When at least 2 shots are being hit, we will combine the exactly 2 shot hit with the exactly 3 shot hit. And this will be the required probability that will come to 2 by 3. The probability of student A passing an examination is 2 by 9. So PA passing the examination is 2 by 9. Student B passing is 5 by 9. So these are all given in the question. Assuming that 2 events A passes and B passes are independent, find the probability of only A passing the examination. So A is passing the examination means what? We'll do it here only. If A is passing the examination means B will not pass. So PA passing is by itself indicating that it is PA intersection B naught. A pass, B doesn't pass. So this will be PA multiplied by PB naught. So PA is 2 by 9. What is PB naught? 1 minus 2 by 9. That is going to be 7 by 9. I'm writing it here only. Call it as PA naught. How about PB naught? PB is given 5 by 9. PB naught is 1 minus 5 by 9. That is going to be 4 by 9. In PA, we are going to write 2 by 9. PB naught. We have just computed it 4 by 9. So this is going to be 8 by 81. Then the second part. Second part is asking only one of them is passing the examination. What does it mean? That is A passes, B fails. This has to happen together. Or B passes and A fails. So A complement intersection B, and we need to add them in order to get only one of them passing the examination. So this probability, these two combined, is actually what we are finding. You can write it like this. Probability that is P, only one of them passing the examination. So only one of them passing the examination will be combination of A passes, B doesn't pass, A doesn't pass, B pass. So the concept you understood, let's multiply them. That is PA multiplied by PB bar, because these are separate events, independent events. The second term will become PA naught multiplied by PB. So PA is already given in the question, which is 2 by 9. PB is also given in the question. Let's write it here first. It's 5 by 9. PB bar we have computed 4 by 9. And PA bar, which is 7 by 9. So when you write this, you're going to get what? This will be 43 divided by 81. The way of writing or doing it is this. This is the way you are going to write. There are three urns, A, B, C. So urn is a bag or a container kind of thing. It's actually cylindrical or circular. Means you can call it as a 3D shape. So first of it has 4 red and 3 black balls. The second urn contains 5 red and 4 black balls. The third bag is containing 4 red and 4 black balls. So 4R and 4B. One ball is drawn from each of these urns. What is the probability that 3 balls drawn consist of 2 red balls and a black ball? So 1 ball from here, 1 ball from this one, and 1 ball from the third one. I've already indicated first, second, third as 1, 2, 3. So we are going to use this subscript. So this means we need to get 2 red ball and 1 black ball. How do we write this? Because there are certain combinations which will eventually fulfill this requirement. What is this? So first one, red coming from the first one, second also producing the red ball, and third one we are getting the black ball out of it. So R1, R2, RB3. Coming from the first one is red, second gives B black, and third also gives red. There is one more combination. It has to be RRB, RBR, or third one can be BRR. So black, red, red. This is R3. So now you see the rows and columns, they are similar. That is, any row or column you take, it will be 1 black and 2 reds. So RRB, this row and column, if you see first row and first column, the R1, R2, B3 and R1, R1, B1. All these have 2 R's and 1 black. So now take the intersection of these, the first row. So PR1 intersection R2 intersection B3 is the first term. The second term is PR1 intersection B2 intersection R3. This is the second term. Third term will be probability of B1 intersection R2 intersection of R3. Now these are 3 different terms which are going to be added in order to get 3 balls as 2 red balls and black balls when 1 ball is drawn from each of these urns. So we will write the probability like this. Probability of 2 red and 1 black. This equals, now you have to write everything. I'll just show you what you have to write, because in probability theory, writing is very important because there is no formula here. There are just logic and reasoning. This goes, first one I'm writing PR1 intersection R2 intersection B3 as PR1 multiplied by PR2 multiplied by PB3. The second term PR1 intersection B2 intersection R3 becomes PR1 multiplied by PB2 multiplied by PR3. The third one is probability of B1 intersection R2 intersection R3, PB1 multiplied by PR2 multiplied by PR3. Now taking the probability, the values actually, and now putting it here, getting a red. First the best way is to do this, that in all you know that there are 7 balls in the first bag or urn, there are 9 balls in the second urn and 8 balls in the third urn. So wherever you get R1, wherever you have R1, in the denominator you write 7, because these are the total number of cases and that will remain unchanged. So just write 7 wherever you get the 1 as a subscript. PR1, PR1 and PB1 all will have 7 in the denominator. Similarly, you have 9 for the second urn. So you have 9 here, 9 here, here 9, no, not here. I'm cancelling it. 9 only for the subscript of 2. So wherever you get subscript 2, you're writing 9 in the denominator. Coming to the third urn, we have 8 in all. So wherever you have 3 as the subscript, just place 8 in the denominator. Now what is the red in the first one? 4. Red in the second one? 5. Black in the third one? 4. Not here. Now red in the first one? 4. Black in the second one? 4. Red in the third one? 4. And now the final one. First one has 3 blacks. Second one has 5 reds. Third one has 4 reds. So these 3 are separate terms and we will multiply them and then we'll combine these 3 terms. So the final computation will give you the result as 17 by 42. Now this is how we are going to write it. If you are able to make the boxes, that will be more additional value addition to this question. Now X is a person, student you can call. Now he is taking up subjects, 3 subjects for the examination: mathematics, physics and chemistry. Now his probabilities of getting grade A in these subjects are given, which is 0.2, 0.3 and 0.5 respectively. We have to find the probability that he gets grade A in all subjects, grade A in no subjects, grade A in 2 subjects. So let's write what all is given first. So first is getting A in math. So this will be our first probability, which is already given in the question. The second probability, which is already given in the question, is A grade in physics, the second subject, A grade in physics. The third probability will be A grade in chemistry. So there are 3 subjects, 3 probabilities already given. I'm just writing for the sake of completion. Otherwise, you know it is 0.2 for the first case, 0.3 and 0.5 respectively for physics and chemistry. Now this is the probability of getting an A grade. What is the probability of not getting an A grade? You can call it, or it's up to you. You can call this first one as PM, the second one as PP, the third one as PC. Most of the people do that. But here the middle one, PP, will get us into some confusion. So let's call it as PA for probability of A in math. Probability of getting A grade in physics is PB and probability of getting A grade in chemistry is PC. So what is the probability of not getting A? It will be 1 minus 0.2. That comes out to be 0.8. Probability of not getting A in physics, this comes out to be 1 minus 0.3. This comes as 0.7. So this becomes 0.7. Now probability of not getting A grade in chemistry, which is PC bar or PC complement, 1 minus 0.5 is 0.5. So we are going to utilize in just a bit. The first one is grade A in all subjects. That is mathematics, physics as well as chemistry, all the 3 A. So getting grade in all subjects, that's how we are going to write as probability. And this is nothing but probability of A, B and C all together. So A, B, C we write, we intersect them as per the probability, and this is nothing but PA multiplied by PB multiplied by PC, because these are the independent events. So what is PA here? 0.2. PB here 0.3, and third one comes out to be 0.5. So this becomes 0.03. 5 is a 15, 15 to the 30. 30 divided by 1000 is 0.03. Now coming to the second one, which is grade A in no subjects. No subject means neither mathematics nor physics and not in chemistry. So neither A nor B, neither C. A complement, B complement, C complement, intersection. Again same thing we'll do, because these are independent event. We'll multiply them separately. PA bar multiplied by PB bar multiplied by PC bar. What is PA bar? We have already computed. 1 minus 0.2 is 0.8 and PB bar is 0.7 already computed, and similarly we have 0.5 for not getting A in chemistry. When we multiply this, we are going to get 0.28. Now third one also I'm doing it on this particular screen only. So this is the third one. Grade A in 2 subjects. What does it mean? It means grade A not in one subject. That is math, physics and chemistry. So 2 at a time. So math, physics but not in chemistry. Again MPC I'm writing 3 times. So first case, in math and physics A, but in C no A grade. In the second one, math and chemistry A grade but physics not getting an A grade. In the third case, it will be math not. That is not getting A in math but getting A in physics and chemistry. So in terms of probability, we will write like this: getting grade A in 2 subjects, or you can call it as exactly 2 subjects or only 2 subjects. All these lines they have the same interpretation and the answer. So P not getting grade A in math plus this will add up to 3 different probabilities. First one is not getting grade A in mathematics. The second one will be not getting grade A in physics, and third one will be not getting A grade in chemistry. So this already I showed you. Just combine them or write them in a proper A, B, C manner. That is going to be A, B, C bar, A, B bar, C, and A bar, B, C. So I'm writing it just for explanation that we are talking about math, physics, and chemistry. We'll change it to ABC just now, but this is what I have written, and I'm changing it to the probability. That is, the first one no chemistry, second one no physics, and third one no mathematics. Others getting a grade A. This is going to be PA multiplied by PB multiplied by PC bar. All these probabilities we have already computed. Probability of A, probability of B bar, and probability of C. Third one is probability of A bar. I'm writing MM. I'll just change it to in a bit. Probability of A bar, probability of B, and probability of C. Now just replace or place the value in the desired probabilities. Wherever you have PA, the better way not to get complicated. The best one is to write PA everywhere wherever you get PA. What is PA? It's 0.2. So I'm writing for PA 0.2 wherever I encounter it. Then PB. PB is what? 0.3. So wherever I get PB, I'm replacing it by 0.3. Now PC is 0.5. So wherever I'm getting PC, I'm just writing it 0.5. Now coming to PC bar. Wherever you get PC bar, 0.5. You'll get PC bar, PA bar, PB bar only one time. Now coming to PB bar, PA bar, PC bar, we have replaced it now. When you compute this, it is going to be 0.22. That's your correct answer. Now this is how you're going to do or write it if you ever happen to write it. Now this question is a good question, let me tell you, and the question which is coming up also has the same process or steps. Now this question will need us to know the geometric progression. GP is 1 plus A square. It goes up to infinite or infinity. So the common ratio, if you divide two values, consecutive values, you'll get almost the same value, always the same value, which is the, not almost, it's always, and which is called the common ratio. The summation or addition of this GP is 1 by 1 minus A. A is the common ratio. So A and B take turns in throwing 2 die. The first to throw 9 being awarded the prize. Now first A will start, then B will follow. It's given clearly in the question. The first to throw 9 being awarded the prize. 9 being means there are 2 dice. They are going to be added up. The number which will turn up will add up. And the number which is turning up when they are added, it has to come as 9, and show that their chance of winning are in the ratio 9:8. So we'll separately compute the probability of both of them, A winning and B winning, then we'll divide them. It has to be 9:8. The probability of getting a 9. So you have to write inside the bracket all of it. Probability of getting a 9. And this is equal to what? There are multiple options. 5, 4, 4, 5, 6, 3, 3, 6. Can you find any other number on the numbers which adds up to 9? No. So these are the 4 possibilities. These are the 4 favorable cases we have. 5, 4, 4, 5, 6, 3, and 3, 6. Now probability is 36 in all, because 6 into 6, 6 in one die, 6 in another die, and 4 is the 4 favorable cases. It comes out to be 1 by 9. Now this is probability of getting a 9. Let's call it as PA. We'll call PA bar as not getting a 9. Now what is the chance of winning when A starts, B is followed? There are multiple ways in which A can win, and there are different ways in which B can also win. So let's understand those possibilities. So when A is going to win and when B is going to win, I am going to show you both of them in the same screen side by side, so that you understand well what is actually happening. So how A will win? First, A is starting, so A can win at the first time, in the beginning as well. Now A can win only when A fails, then B has to fail. Then again A will try and A will win. The third option or third way is A does not win, B doesn't win, A again doesn't win, B doesn't win, then A wins. So wherever the A chances come after B, the A can win. So this P probability, which is 1 by 9, we P bar, or you can call it as PA also, as per your convenience. Nobody is going to stop you for that. I'm just indicating one is P, one is P bar or P complement is 1 minus 1 by 9, which is 8 by 9. So the probability of not getting a 9 is 8 by 9. The probability of getting a 9 is 1 by 9, and probability of not getting a 9 in both of these die is 8 by 9. We are going to apply that. Now let's understand how B is going to win. B can win only when A has tried. So A fails, then B wins. The second option can be A fails, then B fails, then A again has to fail, then B can win. Then the A doesn't win, B fails, A fails, then B fails, then A fails, then B can win. So B, whenever he gets chances, B can win. And the chances are only when the previous all throwing has resulted in not getting 1 by 9. So this PA plus PA not B not A, I'm just writing what I've discussed with you. Now PA bar intersection B bar intersection A bar intersection B bar intersection A, and this goes on and on forever. Side by side, the B winning probability also let's write A naught B, so A naught intersection B plus P A naught B naught A naught and B. So A naught, B naught, A naught and B intersection. The third possibility is, this goes infinite because these are three possibilities which I've shown you. But just imagine this is going to go forever. This game is unending. So A bar, B bar, A bar, B bar, A bar and then B. Now what is the probability of A? Whenever you write, it is probability of A and probability B together, because they both have to get a 9. They both have to not get a 9. So PA equals PB, because I have to write these values in the expression we have developed after discussion. This PA PB is 1 by 9, PA bar and PB bar is 8 by 9. These two persons are going to get these same probabilities. So PA is 1 by 9. Now replacing, because PA bar into PB bar into PA, because you can directly multiply them. These are independent events. So PA bar is 8 by 9, PB bar is 8 by 9, and this PA is 1 by 9. Now you don't have to write all these, because you will understand that it follows a pattern, and this pattern is called the geometric progression. Coming to the B winning side by side, A bar and B, so multiply these two. PA bar is 8 by 9, PB is 1 by 9, PA bar multiplied by PB bar multiplied by PA bar multiplied by PB. This is going to give you 8 by 9 multiplied by 8 by 9 multiplied by 8 by 9 and multiplied by 1 by 9, because here B is winning. Now I am going to let it go forever, because we will know the pattern in just a bit. So if you closely watch, PA is 1, these are 3, 5. So all the odd one, A wins, odd, and all the even, B wins. So 1 by 9 I'm taking outside. When I take 1 by 9 outside, 1 will be remaining in the first term, 8 by 9 into 8 by 9 in the second term. And I told you 1, 3, 5, and we have taken one member out. So it will be 1, then 2 times 8 by 9, and then 4 times 8 by 9, then 6 times 8 by 9, then 8 times 8 by 9, and it goes forever. So multiply 8 by 9 4 times here, and that you don't have to write the next term because it goes on and on. Here what we do, now one idea is to take 1 by 9, but we will remain with 8 by 9 plus 8 by 9, 8 by 9, 8 by 9, 3 times. But the problem here is geometric progression. We need 1 at the beginning. Now at 1 in the beginning, we need to take this 8 by 9 out also from the second series. Let's do the first one first. So we have 1 by 9. 1 plus 64 by 81, because 8 is 64, 9 is 81. This is 64 by 81 2 times, so let's call it as 64 by 81 whole square. Now 1 by 9 I'm taking outside, 8 by 9 also you can take outside this one. I'm just requesting you that if you keep like this, 8 by 9, 8 by 9 whole cube, 8 by 9, 8 raised to 5, the problem remains still. We need a 1 as I just suggested. So let's take this 8 by 9 outside. But when you take 8 by 9 outside, what are going to remain inside? We'll get a 1, which we desperately want. So this is going to be 8 by 81. Now 1, since 8 by 9 is taken out, just reduce the power to 1 by 1 actually. So 64 by 81 here, 64 by 81 whole square in the next case, and it goes on and on. Now what do you see here? After 1 by 9 and after 8 by 81, they both are same, values are same. One is PA, one is PB. we eventually want to find out the division of this, because we want to find out the ratio. PA by PB is what is being asked from us. So just divide these two. When you divide these two, the second part of each term, which is actually 1 plus 64 by 81, 64 by 81 whole square, this will get cancelled. But we need to compute it. And this summation, I already told you, it is 1 by 1 minus A. A is the common ratio, which is 64 by 81 in this case. And this will be exactly similar in the second case also, which is the probability of B winning. 8 by 81 comes outside, 1 by 64 by 81, which is there. So what we got? 1 by 9, 1 by 1 minus 64 by 81. This is your PA. After discussing all, we got PB as 8 by 9, and then we have 1 by 1 minus 64 by 81. Now we know when we divide it by, it is simply 1 by 9 divided by 8 by 81. But we will do the activity completely. This 1 minus 64 by 81 is 17 by 81. 81 goes up, 81 by 17 in both the cases. Now again, let me reiterate you, PA by PB has to be computed. So I'm just taking PB and putting it in the denominator of PA. When I place it, 81 by 17 gets cancelled. 1 by 9 divided by 8 by 81. 81 goes up, 8 comes down. 9 9s are 81, it cancels out. And this comes out to be 9 by 8, and that is what is being sought from us. Alright, PA, PB is separately computed. We divided them, and when we divided them 9 by 8, 9 is to 8 has to come. And this is nothing but 9:8. So this was a good question. This question is to be done in this manner. It's a concise way of representing it. A, B, C in order, toss a coin. So first A has to start, then B followed by C. The coin can give you head and tail. So probability of getting head is half, probability of getting a tail is half. What are their respective chances of winning, assuming that the game may continue indefinitely? We already know in the previous question we have seen that this goes on and this will go on and on forever. So we'll do it side by side. Probability of A winning, probability of B winning, and third one is probability of C winning. So this goes side by side. Why? Because I want to show you the differences and the similarity when we compute them. So we are to talk about probability of getting a head and probability of getting a tail. Probability of getting a head is half, probability of getting a tail is half. 1 by 2, 1 by 2. That means whatever probability you are going to write, whether A or A complement, B or B complement, C or C complement, every time we have to write half only. There is no change. So A wins when A starts, A can win. Then A doesn't win, B doesn't win, C doesn't win, then A can win. Then A doesn't win, B doesn't win, C doesn't win. Then A again doesn't win, then B doesn't win, and C doesn't win, and then A wins. So these are different possibilities which goes on and on. Coming to B, A has to lose, then B wins. Then A lose, B lose, C lose, then again A lose, then B wins. You can do the third one. Let's come to C. A lose, B lose, then C wins. Or A lose, B lose, C lose. A lose, B lose, then C wins. So this goes on and on. Now probability of A, let me formally write. Probability of A, that is A wins, is half. Probability of A doesn't win is 1 by 2, because head and tail both have similar probability. They are identical, half and half. Now probability of B also goes like this. Probability of B winning is half, probability of B losing is also half. Probability of C winning is half, probability of C not winning is half. So basically it's just PA plus PA bar intersection B intersection C bar intersection A. Probability of A intersection B, A naught, B naught, C naught, A naught, B naught, C naught, A intersection. How about B? It's P A naught B intersection plus probability of A naught, B naught, C naught, A naught, B. C is A naught, B naught, C all intersected. Probability of A naught, B naught, C naught, A naught, B naught, C all under intersection. Now let's write the probability. Please remember, these are all independent events. We just have to multiply these separate probabilities and add them up. So PA is half. There are 4 A, B, C, A naught, B naught, C naught, A. All, doesn't matter, all will be half. Here we have 6 of them. Or no, 1, then 4, 1, 2, 3, 4, 5, 6, 7, 7. 1, 4, 7. Always 3 are being added. So write half 7 times. So half plus 4 times half plus 7 times half. Now coming to the B wins, there are 2 of them, half into half. Then 1, 2, 3, 4, 5. 5 of them, write half 5 times. How many times? 5 times. Again here 2, then add 3, it becomes 5. In the third case also there are 3, then you add a 3, so it will be 6 times. So that is how you see the similarity and the commonality also, and the differences also. So I was completing the B1. Let me complete this. Coming to this third one, which is the C part. So half into half into half 3 times, then 6 times half. So half multiplied 6 times. So this is how, and this goes on and on, this goes on and on, this goes on and on. Now what we have to do is we have to take a half. As I told you, this is a geometric progression. Geometric progression has the summation to the infinite series as 1 by 1 minus a. So I have taken half outside. Whatever is remaining, don't multiply these number of times, just write it as a power. 1 plus half raised 3, half raised 6, dot dot dot, goes indefinitely. Here 1 by 2 whole square we are taking outside. It comes out to be 1 by 4. 1 is remaining. Here we have taken 2 of them. So 1 by 2 to the power 3 remains. Then this goes on and on and on, because you know that 1 by 6 will come. Now the differences is only the coefficient, but the internal matter, which is 1 plus half cube plus half raised 6, remains same in all these 3 separate cases. If you take half into half, that is 1 by 2 to the power 3 common from the third one, 1 plus half cube and half raised 6 will come out. So all these 3, which is the second part of each term, remains same. So these are 3 separate things. I would have done it separately, but this wouldn't have given you a proper picture what exactly we are trying to do. Now I'm doing the second part, which is 1 plus half cube plus half raised 6 plus half raised 8 9. I'm adding 3 3 3, right? So this, if you divide any of these 2 consecutive terms, if you divide 1 by 2 raised 6 divided by 1 by 2 raised 3, or 1 by 2 raised 9 divided by 1 by 2 raised 6, every time you are getting 1 by 2 raised 3. So this a is 1 by 2 raised 3, which is 1 by 8. And the summation is 1 by 1 minus a is the common ratio, which is 1 by 8. So 1 by 1 minus 1 by 8 we'll write. And this comes out to be what? Denominator will be 8 minus 1 by 8, that is 7 by 8. And this 7 by 8, this goes up, so it will be 8 by 7. So the second term is 8 by 7 in each case. First remains same, half into, in the probability of A winning game, half multiplied by 8 by 7, because the second part we have computed just now. And the second one, which is B winning, when B is winning, it's 1 by 4 as the coefficient, which you see here, multiplied by 8 by 7 in this case. Coming to the probability of C winning, when C wins, it's all about 1 by 2 to the power 3, which is 1 by 8, and followed by 8 by 7, which remains same for all these 3. This comes out to be 4 by 7, 2 4s are 8. So 4 by 7 is the probability of A winning the game. This comes out to be 2 by 7, B winning the game. And the probability of C winning the game is cancel out 8, 1 by 7. This is your answer. So this A winning, B winning and C winning has to be computed separately. And this is how this will be done. This geometric progression is very important, which you should recall and apply in this question. 3 persons A, B, C throw a die in succession. Now this question you need to understand very well, because the 35th question is exactly like this. So 3 persons, they throw a die in succession till one gets a 6 and wins the game. There is a die. 3 people throw in succession. So 1 to 6 can come for the first one, followed by 1 to 6 can come for the second one, and 1 to 6 can appear for the third one. Whoever gets 6. So how many possibilities are there? 6 is only 1 in 1 to 6, and in all possibilities 6. So 1 by 6 is the probability of getting a 6. So you can just call it as probability of getting a 6, which is true for all of them, A, B, C. So probability of getting a 6 is 1 by 6. And probability of not getting a 6, that is 1, 2, 3, 4, 5 appears. This is simply 1 minus 1 by 6. So this is going to be 5 by 6. And this is what we are going to use a lot in this question. So please understand these 2 probabilities. Now geometric progression is the key here, which we are going to use a lot. 1 plus A square plus A cube, this goes on and on to infinity. Now if you take any 2 consecutive numbers and you divide them, the ratio remains constant and for the entire series. So this is 1 by 1 minus A. A is the common ratio. This is the summation or sum of the series that which we are going to use just now. So let's call these three as A, B, C. Now what is the probability of A winning? Then what will be the probability of B winning? And third is the probability of C winning. Now I want to show you all of them together so that you understand the commonality and the differences between the approach. Now what happens? A starts. So A can win at the first go. He is lucky, fortunate enough. Then if A wants to win, A has to lose, B has to lose, then C has to lose, and then A comes. Means the option of A comes, then A will win. Or A fails, B fails, C fails. Then again A fails, B fails, C fails. Now the chance of A winning comes and he wins. So these are the different possibilities of A winning. Now when B has to win, so B chance comes only after A. A losses, B wins. A losses, B losses, C losses, A losses, then the chance of B winning comes. Or A loses, B loses, C loses. A loses, B loses, C loses. A loses, then B's option will come and he may win. Now for C, A and B has to fail. The second option is A, B, C, A, B, they have to lose. Then C comes. The third option here is, and this is not the third and the last option, this goes on and on forever. So A, B, C lose, then again A, B, C lose, then A, B lose, then C comes. So this is the approach or the logic of this question, that when A wins, when B wins, and when say C wins. So we just call it as a probability of A plus probability of A bar intersection, B bar intersection, C bar intersection, and A intersection. And this all goes A, B, C, A, B, C intersection, bar intersection with A. And this goes till infinity. Now what is the probability of B winning? With the same analogy, this A bar intersection B, the probability of A bar, B bar, C bar, A bar, and then B comes. Then the probability of A, B, C, A, B, C, A, they all lose, then B comes. And in this, the losing, B is also inclusive because B has to win, so he has to lose some time. Then here for C comes after A and B, so A and B have to lose. Then C again comes after AB, so ABC loses, AB loses, then C comes, or C chances of winning comes here. Or ABC, ABC, AB should lose, then only C. That means whenever C chances come, then only the option of winning and losing will appear. Sometimes he loses, sometimes he wins. So probability of A, probability of B, and probability of C all together winning is 1 by 6. And probability of A losing, probability of B of loss, or probability of C not getting through is 5 by 6. So wherever in this question you see a bar, write 5 by 6. Wherever you see a normal probability, whether it be A, B, C, it's 1 by 6. So I'm just replacing these values. These are independent events. So I'm just writing one of them so that you understand that this PA bar, B bar, C bar intersection with A gives you PA bar multiplied by PB bar multiplied by PC bar multiplied by PA. So plus PA bar is 5 by 6. All bars are 5 by 6 in this question. So 5 by 6 3 times here, 5 by 6, 5 by 6, 5 by 6, 3 times, and then comes PA, which is 1 by 6. Now don't worry about the upcoming terms because we are going to get the result by 1 or 2 only. We need 1 at the first and A at the second. That's what a geometric progression demands for us. Now here PA bar multiplied by PB for the first one. So 5 by 6 multiplied by 1 by 6. This is the first term. The second term is A bar, B bar, C bar, A bar. So 5 by 6 4 times followed by a B. The 4 times 5 by 6 we are going to multiply, followed by a B, which is 1 by 6. Let me reiterate, wherever A, B, C comes, 1 by 6. Wherever A bar, B bar, C bar comes, it's 5 by 6. That's what you have to do. I'm not writing the third one, the third option, because the first and second options are more than enough to constitute a geometric progression or geometric series. Now here also, A bar, B bar, C bar, so 5 by 6 into 1 by 6 in the first term, and this is how it goes on for the second one. All bars are 5 by 6, all normal without bars are 1 by 6. Now I'm going to show you that all these are having a common content. How? When you take 1 by 6 common from the first series, that is PA wins, pi by 6 cube remains inside. And with our previous knowledge, this second one, or third one rather, will be 5 by 6 raised power 6. This goes on and on. Then the second one, this 1 by 6 and 5 by 6, take both of them, 5 by 6 and 1 by 6 gives 5 by 36. Inside this we have 1 plus 5 by 6 whole cube. You have already taken 5 by 6 and 1 by 6 out. So 5 by 6 to the power 3 will remain. All the three terms, all the three series, the second term remains the same. Only the coefficient or the value which is preceding this series are changing. Now I'm taking 5 by 6, 5 by 6 and 1 by 6 outside. This gives you 5 5 is 25 divided by 216 outside. Inside one will be 1 plus 5 by 6 whole cube plus 5 by 6 whole raised to the power 6 again. Now this all, let's compute this one. So 1 by 6 multiplied by the result of the series, 5 by 36 multiply the result of the series, and 25 divided by 216 multiplied by the result of the series is going to eventually come. Now coming to the geometric progression, because we have got the geometric progression series, which is 1 plus 1 5 by 6 whole cube plus 5 by 6 raised 6. If you divide any of these two, let me show you, it is going to come as 5 by 6 raised 3. So you have 5 by 6 raised 6 divided by 5 by 6 raised 3. This will give you 5 by 6 raised 3. So this is 5 by 6 raised 3. 5 5 is 25. 25 into 5 is 125. 6 into 6, 36. 36 into 6 is 216. So you have 1 by 1 minus 125 divided by 216. So I'm writing it here just to let you know. I know that this is quite easy for you, but 216 goes up. 216 minus 25, 125. So this gives you 91. So now multiply 1 by 6 with 216 divided by 91. Multiply 5 by 36 by 216 divided by 91. Multiply 25 by 216 by 216 multiplies by 91. So these are the probabilities of A winning, B winning and C winning respectively. Let me write the final values now in order to conclude this solution. The first one is going to be 36. This goes 636 divided by 91. The second one 30 by 91. The third one is 25 by 91. Now this is how the steps you are going to witness in this reference, and if you are doing it by yourself, write all these. Never let these escape from your writing. A and B take turns in throwing 2 dice. The first to throw 10 being awarded the prize. So whoever gets a 10 gets a prize. Show that A has the first throw, so it's established that A is going to start. The chance of winning are in the ratio 12:11. Now we are going to do this question in a different way. If you remember, we have already completed a question with 9:8 ratio. But here this set of getting a 10. So when you throw a die, the die, whatever number appears, if you add them, it has to come as a 10. So 5 5, 6 4 and 4 6 are the possibilities, because when we add these values, you are going to get a 10. So what is the probability of getting a 10? It's favorable cases, which are 3 in this case, and total number of cases are 36 when you throw a die. So 3 divided by 36, which gives you 1 by 12. Now probability of not getting a 10, and this is going to be 1 minus 1 by 12, and that is going to be 11 by 12. Now A starts followed by B. So A will also win, B will also win, and what are the chances of them winning? The ratio of their chances of winning is 12 by 11. So probability of A wins. Now A will win at the first go. He throws, he gets a 10. Any of these 5 5 6 4 or 4 6. Or if A doesn't get a 10, B has to fail so that A wins. Then A fails, B fails, A again fails, then B has to fail so that A could win. This is nothing but probability of A plus probability of A bar intersection B bar intersection A plus probability of A bar intersection B bar intersection A bar intersection B bar intersection A. So all these goes in intersection because these are an event, a separate event. All these three are separate events, and these events are internally independent of each other. So let's call this PA and PB together as 1 by 12, because both are going to get 10 in order to win. PA bar and PB bar is equal to what? 11 by 12, both of them, because these are the chances of they not getting a 10. So PA, wherever you get A and B, write 1 by 12. PA bar, let me write it like this just to let you know what I am trying to do. PA bar multiplied by PB bar multiplied by PA. So wherever you have a bar, write 11 by 12. Bar is 11 by 12. You get a PA, just replace it by 1 by 12. Now this you can write, you can skip it, because we are already going to get a GP from two numbers or two terms. So if you take 1 by 12 outside, 1 plus 11 by 12 whole square, 11 by 12 raised power 4, 11 by 12 raised 6, 11 by 12 raised 8, will go on and on and on. GP series addition is 1 by 1 minus A. I already explained it to you in the earlier questions. So this 11 by 12, if you take any two terms, 11 by 12 raised 4 by 11 by 12 raised 2, the common ratio is 11 by 12 raised 2. That is nothing but 121 by 144. So 1 by 1 minus this will be 121 divided by 144. So 144 goes up. 144 minus 121 is 23. This is 1 by 12 multiplied by 144 divided by 23. So this is 12 by 23, because 12 times 12 is 144. Now PA wins is 12 by 23. What is the probability of B winning? You can apply the same scenario here also. But rather than doing this, let's find a different approach. If A wins, B doesn't win. If B wins, A will not win. So in order to get the probability of B winning, why not to subtract the probability of A winning by 1? So 1 minus probability of A winning gives you the probability of B winning. So 1 minus 12 by 23 is actually the probability of B winning. So this is 11 by 23. So probability of A win divided by probability of B win, which is what is sought in the question, we have to prove it. So PA by PB is nothing but 12 by 23 divided by 11 by 23, and this goes 12 by 11. This is your final result. So this is the formal way of doing it. If you want to write, this is the way you need to go ahead. There are 3 red and 5 black balls in bag A, 2 red and 3 black balls in bag B. 1 ball is drawn from bag A, 2 from bag B. Find the probability that out of 3 balls being drawn, 1 is red and 2 are black. So these questions we have done already in the previous few questions, and 1 or 2 questions are coming after this also. So I hope that this reference will help you. Fatima and John appear in an interview for 2 vacancies for the same post. The probability of Fatima's selection is 1 by 7 and that of John's selection is 1 by 5. What is the probability that both of them will be selected? Only one of them will be selected. None of them will be selected. So the probability of Fatima, let's call it PF or PA, it's 1 by 7. Probability of J wins, let's call it PJ or PB, it's 1 by 5. So probability of Fatima not making to the interview, it's making means not getting successful, is 1 minus 1 by 7, which is 6 by 7. Probability of John failing in the interview is 1 minus 1 by 5, which goes 4 by 5. We are going to employ this in this question. Both of them getting selected, that is A and B, F and J, both are getting selected. I am representing F by A, J by B. This is going to be PA multiplied by PB because these are 2 separate events. 1 by 7 into 1 by 5, this gives you 1 by 35. Coming to the second one, only one of them will be selected. So A selected, B doesn't, or B gets selected, A doesn't make it. So just intersect them, take the probability, add them. This is nothing but PA multiplied by PB bar or PB complement plus PB multiplied by PA bar or PA complement. All these values are known to us. PA is 1 by 7, PB is 1 by 5, PA bar is 6 by 7, PB bar is 4 by 5. So this is A and B, F, A, J is B. So 1 by 7, 6 by 7 for PA and PA bar. PB is 1 by 5, PB bar is 4 by 5. So just multiply these and add them. So this is going to be 2 by 7. The third one. Now these are A and B. As I told you, this is A bar and B bar. I am replacing it just to get the clear picture because none of them will be selected only when they both have the complement intersected. So neither A nor B, neither Fatima nor John. So F bar, J bar represents A bar, B bar. Probability of A bar intersection B bar is PA bar multiplied by PB bar, and these are already being computed. This goes 6 by 7 into 4 by 5. So when you multiply these two, you're going to get 6 4 is 24 divided by 7 5 is 35, and this is your final result. So this is how you're going to go about it. A bag contains 8 marbles, for which 3 are blue and 5 are red. So before I go ahead, let me show you all the questions which we have already completed. Question number 1, 2, 17, 20 and many more. Exactly or almost similar to this kind of question. So I would suggest you to go back and revisit this question and try to solve it by yourself. Now if you have any problem, then I will show you the results so that you can try when you are practicing it. Now this is how it can be done. So in all there are 8 marbles, 3 blue and 5 red. We have to find out the blue followed by red, blue and red in any order and of the same color. So all this we have already done quite a lot. So this is for you. An urn contains 7 red and 4 blue balls. Now before I go ahead with this question, the previous question which we just did and the solution maybe some people may have some problem up till now also. So let's do this question and try to resolve all the problems which you have until now. 2 balls are drawn at random with replacement. So there is a replacement going on. Find the probability of getting 2 red balls, 2 blue balls, 1 red and 1 blue ball. So in all there is a urn or a box where we have 7 red and 4 blue. That means in all we have 11 1 balls. So what is the probability of getting a red and a blue balls? Because we need to find out 1 2 3. Before that, let's say that we find out this probability of red and probability of blue. This PR and PB are representing the probability of getting a red and getting a blue balls. So since they are coming from the same box, the denominator will remain the same. Probability is in the denominator, it comes total number of cases. So 11 is the total number of balls, 11 will come in the denominator. So what is your favorable cases? When you want red, there are 7 reds. So any one out of 7 can come. So 7 is the numerator. For the blue, there are 4 possibilities. So 4 should be placed in the numerator. So now we got the probabilities here. So the probability of getting 2 red balls, that means the first one should come red and the second should also come red. So this is the probability of R1 intersection R2, R1 followed by R2. So this is PR1 multiplied by PR2 because these two are the independent events. And this R1, R2 goes up to R7. That is, there are 7 red balls. So the probability remains similar for PR1, PR2, PRN till 7. So this will be 49 by 121 when we multiplied 7 into 7 divided by 11 into 11. Now coming to 2 blue balls. So probability of getting 2 blue balls is exactly similar to how we computed 2 red balls. So the probability of, we call the first ball as B1, the second ball as B2. So this is nothing but probability of B1 intersection B2. B1 coming, then B2. And this, all the balls are similar. So it doesn't matter B1, B2, B2, B1, any ball can come. These are independent events, just multiply them separately. PB1 multiplied by PB2. This will give you probability of B remains the same for each B. So 1 to 4, any ball, probability remains the same. So PB1 is also 4 by 11 and followed by 4 by 11. This gives you 16 by 121. Now this is the second one. Now the third one. 1 red and 1 blue ball. Now this red can come first, blue can come later. A blue can come first, red can come later. There is a possibility of that. So 2 balls should be the outcome. They haven't said us the first should be red and the second should be the first red and second should be a blue ball. They haven't said that. It can be any of it. So it has to be 1 red and 1 blue ball. So first red, second blue, or first blue, second red. So probability of R1 intersection B2, red from red first ball and blue second ball, plus probability of B1 intersection R2, that means blue the first ball, red the second ball. Now since these are independent events, just multiply them. PR1 multiplied by PB2 will be the first term. The second term will be PB1 multiplied by PR2. Now all these probability we know. The red probability, whether it is PR1 or PR2, it remains the same. So we have this from 1 to 7, any red ball, 7 by 11. So whenever you get PR, whether you have the subscript 1 or 2, just write 7 by 11 there. Coming to this B, the probability of blue ball is 4 by 11 wherever you encounter it. So when you multiply this, this is going to be 2 into 28 by 121, and that is going to come as 2 into 7 into 4 divided by 11 into 11, that is, it's 56 divided by 121. So all these questions which I showed you in the earlier question and this question, all these will make you comfortable if any of this sort question appears to you. A card is drawn from a well shuffled deck of 52 cards. The outcome is noted. The card is replaced and the deck reshuffled. So there is a replacement proper. So here we have 52 card in all. You know all the card terminology, all right? I assume that. Then we'll be able to solve this 52 card or deck of card problem. What is the probability that both the cards are of the same suite? Both cards should come from the similar same suite. So the first one which we are going to compute is both cards. This you have to write. Both cards should come from the same suite or suit, whichever way you pronounce it. So how many suite are there? The diamond is one of the suite. In all there are 4 suites. All of them contains 13 number of cards. So in all there are 52 cards. And what are the different names of the suite? We have the diamond. Both the cards which we are drawing can be diamond, they can be spade, they can be clubs, and they can be hearts. Now if you compute the probability of, say, diamond, 2 cards from the diamond, all the others like this, it comes from the spade or clubs or let's say heart, it remains the same. There will be no change, because in all the suite there will be 1 queen, 1 jack, 1 king and 1 ace, and from 2 to 9 there will all be numbers. So let's say it's diamond. How many diamonds are there? 13. How many cards are there in all? 52. So probability of getting a card from the diamond suite, 13 is the favorable cases, 52 are the total number of cases. So 13 by 52 is our probability of getting a diamond. Now since the replacement is happening, the probability of getting the second diamond will also remains the same. It will be 13 by 52 only. That means when we write this, both cards are of same suite. That is, we are intersecting D1 and D2. Probability of D1 intersection D2 and the probability of S1 intersection S2. Because there are 4 different suites, you have to do or execute it for all the 4 suites. So the first is diamond, second is spade, then we have clubs, then we have hearts. So even if you call it as PD1, PS1, PC1, PH1, doesn't matter. They will remain, the probability will remain as 13 by 52, which is 1 by 4 essentially. Probability of let's say D2, doesn't matter. It will be D2, S2, C2, H2. Probability of any of this card will remain as 13 by 52. It remains unchanged because there is a similarity. All are identical. They are exactly similar. Just the colors are different. Just the symbols are different. So this first can be written as PD1 multiplied by PD2. The second can be written as PS1 multiplied by PS2. Third goes like this, PC1 multiplied by PC2. The fourth one goes PH1 multiplied by PH2. Now there are two probabilities multiplied and then added with the 4 probabilities. So 13 by 52 put everywhere. Wherever you get the probability, in this case is 13 by 52. So I'm replacing every probability by 13 by 52 in all. So what you see here is 13 by 52 everywhere. You can just assume it like this. These are for the separate suites. So just multiply 4 and compute 13 by 52 into 13 by 52. 13 by 52 is 1 by 4. 4 gets cancelled and only 1 by 4 will remain. Now coming to the second part. What is the probability that the first card is an ace and the second card is a red queen? So first should be an ace. First card is an ace and second card is a red queen. So it's clearly specified that the first card should be an ace. It's not saying that any of the card can be ace or a red queen. So probability of ace multiplied by probability of red queen. Let's call it, let's write it like this. Probability of ace and red queen. So this is probability of ace followed by a red queen. In terms of probability, we can write it as PA intersection R. And since it is a queen, I'm writing a subscript Q. So we essentially have to find out PA multiplied by PR subscript Q. Now this is just for representation. You can use any word, any symbol, anything which you want. So how many aces are there? There are 4 aces in all. In a 52 deck of card, there are 4 aces, one from each suite. So there are 52 cards in all, 4 aces are there. So 4 by 52 is the probability of getting an ace. The probability of getting a red queen. First of all, how many red cards are there? There are 26 black cards and 26 different color cards, which is the red cards. So black and red, there are 26 of them. So red and black, 26, no problem. Now you want a queen from the red card. So in this red cards, there will be 2 different suites. So 2 queens will be there. So you need 2 queens from 52 cards. These 2 queens are red and queen from 26 cards. But there are 52 cards in all. So in all, there are 2 red queens in 52 cards. So the probability of red queen shall be 2 by 52. So 2 by 52, write it here. And when you multiply this, you are going to get 1 by 338. Now, how do we solve this? This question was a good question, and this is how you are going to solve it. Out of 100 students, 2 sections 40 and 60 are formed. If you and your friend are among 100 students, what is the probability that you both enter the same section? You both enter the different sections. Now, what you see here, you both enter the same section and different section are actually the invert of each other. So if we are able to find out any one probability, the second can be computed just by subtracting it from 1. That is first thing you need to keep in mind. Now we have 100 students. There are 2 groups to be made. One group will contain 40 students. The other will contain 60 students. Now what is the probability that you both enter the same section? So you are 2 guys. Now you can enter in the section where we have 40 students, or you guys both can go to that section which contains 60 students. But remember, you 2 are already included in 40. You 2 are already included in 60. So if you take yourself out, there will be 38 students in one category and 58 students in the another category. So the first thing is both should enter, or both will enter the same section. So the probability will be something like this. We'll call it as PS for same section, PD for different section. This is my symbology, my letter which we have taken. You can take any letter. It's up to you. So probability is what? Total number of cases in the denominator and favorable cases comes in the numerator, that you already know. So there will be 2 possibilities. You both can go in this 40 category or 40 student section. You both can go in the 60 category or 60 numbered section. So here we have, in all 100 you are 2, 98 are other kids, other students. If you want to go, or if you are going to the section of 40, 2 are you, 38 are other students. So the first probability, which is you are selecting, or the management is selecting 40 out of 100, that is the selection of total number of cases. But your favorable cases, if you are going to 40 section, in this 40, 2 are you. In this 40, 38 are others and 2 are you. So how these 38 will be selected? Because you are thinking about yourself, but there are other students also. So we need to think about them also. So others will be taken from 38. So the 38 should be taken, or will be taken from 98. So 98 C 38 is the favorable cases, because it is assumed that you are anyway going to this section. So you can be removed. Others needs to be arranged, right? Now this is done. Now let's come to the 60 part. Now if you are in this 60 section, or you're going to this 60 question, the same logic will apply. Now the total number of cases, in all there are how many numbers? 600. But in that section 60 has to be selected. So this will be 100 C 60, selecting 60 from the 100 students. This is the total number of cases. Now in this 60, as I told you, 2 are already fixed, they are you. But what about 58? And 98 are remaining, because 2 are you. So in this 98, now the choosing or selection has to be done for other 58, 98 C 58. So these are 2 separate but related events of you going to either 40 category or 60 category. Now this NCR is factorial n divided by factorial n minus r factorial r. NPR is factorial n by factorial r. So this n is, in this numerator, n is 98, r is 38. So just put in here factorial 98, factorial 38, factorial 98 minus 38 is 60. So 60 comes here in the denominator. Factorial 100, factorial n divided by factorial r, which is factorial 40, factorial n minus r. 100 minus 40 is again 60. This first probability is probability of you going to the section 40 and probability of you going to the section 60. Now these both are to be added as I indicated earlier. So the numerator now becomes, for the second part, is factorial 98 divided by factorial 58 and then factorial 98 minus 58, which is factorial 40. Denominator will be what? Factorial 100 divided by factorial 60, and 100 minus 60 is 40. Factorial 40 is factorial 40. I've written 40, so just correct it. So we have factorial 98. This goes, factorial 40 goes up, factorial 38 and factorial 100 remains in the denominator. How about the second term? 40 goes, these are factorial 40, factorial 60 goes up, factorial 98 is already upstairs, factorial 58 is already below, and 100 also follows factorial 58. Now the better way is to do it here, or you can do it, you can reduce your effort by taking this factorial 98 by factorial 100 common. So let's take this factorial 98 divided by factorial 100 outside so that you don't compute it twice. So I am taking this factorial 98 divided by factorial 100 outside. Inside will be factorial 40 divided by factorial 38 plus factorial 60 divided by factorial 58. Now let's compute it separately. 40 will be 40 into 39 factorial 38. 38 is in the denominator, is below. 40 into 39 will come as the first element. Now factorial 60 by factorial 58, 60 and 59 will remain because 59 can be followed by factorial 58. 58 is already down below. You can cancel these two. 60 into 59 will come. Either you just multiply 39 into 4 and 59 into 4, add them and add a 0. Or let's do this first, 98 and 100. Factorial 98, just write it like this. Denominator will become 100 multiplied by 99 factorial 98. This you can cancel, so the denominator will contain 1 by 9900. 99 into 100 is 9900. Now let's compute this. I've already computed this. 40 into 39 comes out to be 1560. 60 into 59 will come as 3540. When you add them, this is going to be 5100. Now multiply 99 by 100, 9900. So eventually 5100 or 5100 is divided by 9900, and that comes out to be 17 by 33, or you can call it as 0.51. Now we have already computed the first part, that you both enter the same section. The probability of same section is 0.51. Now second part says you both enter the different sections. That means you are not going to the same section. So you have 100 students, you have 60 and 40 as two categories or two sections. Now you are two friends, you and your friend. You have to go to 60 and the other has to go to 40, or vice versa. Now the same section probability, as I indicated you earlier, this has already been computed. So if you subtract the 0.51 or 17 by 33 from 1, then you will get that you both enter the different sections. This probability of different section, I'm indicating it with PD. 1 minus 0.51, which is going to be 16 by 33, is going to come as 0.49. 16 by 33, 17 by 33. If you happen to add them, this probability will be coming as 1. Try it, you'll get it. So this is a very good question. It will always come in 5 or 5+ marks. Please remember, and this question needs a lot of effort, which I already explained it to you. So these two different probabilities have to be added in order to get 17 by 33, that both are going to the same section, and then you subtract this 17 by 33 in order to get both are entering the different section. Alright, in a hockey match, both teams A and B scored the same number of goals up to the end of the game. Now, why I'm not reading it? Because this question has, after what I read, has the same content here. That is, these die has to be thrown, and whoever gets, which captains are whichever captains A and B gets a 6, he wins. And we have done a complicated question of 3 persons. Here only 2 A and B teams are there. But we are doing A, B, C. We have already done it, which is question number 27. This question is already been done. You can just go to the 27th question, follow the instructions, and then you can do this question. So this is how this question will be done. I am presenting you the result. If you happen to have any problem, you can just follow this. This question is going to use the geometric progression, and 6, of course, you know the probability of getting a 6. Now, we have just left the previous question, and most of you will get, oh, he has left a question. This is not done. So let's do this question. This question is exactly similar to the question number 35 and question number 27. So let's do this question in order to recall what we have already completed. So A and B throw a pair of dice alternatively. A wins the game if he gets a total of 7, and B wins the game if he gets a total of 10. So the complication level is higher here. They both are not going to get 7. One, if he gets 7, then he wins. The other, if he gets 7, 10, then he wins. And please mind it, they have already given that A starts the game, and probability of B winning has to be computed. So probability of A with getting the 7 is the starting point. All other natural language, English language, you have to write wherever it is required. The sample space of getting a 7 is 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, and 4, 3. If you add any of these elements, you'll get a 7. So number of elements in this set is 6. So probability of getting a 7 is 6 divided by 36, because in a pair of die, always the total number of cases remains 36. So this is going to be 1 by 6. Now probability of not getting a 7 is, you subtract this from 1. So 1 minus 1 by 6, it is going to be 5 by 6. Now what is the probability of getting a 10? So this sample space or the set I'm making of 10, when 10 will come? When you add 5, 5, 2 dice, 6, 4 or 5, 6. So there are only 3 possibilities you get a 10. So number of elements in this set is 3. So the probability of getting a 10 will be 3 divided by 36, which comes out to be 1 by 12. The probability that 10 is not going to come is 1 minus 1 by 12, and that is going to be what, 11 by 12. Now A and B do it alternatively or alternately. So we'll start with A, and then we see how B wins. So the first thing comes is A is going to start. When A starts, he has to fail so that B wins. So B will only win when A will fail. This is the first case. Now what will happen in the second case or the next case? A has to fail, B has to fail, then again A has to fail, then B will pass or B will get a 10, right? A don't get 7, B don't get 10, A don't get 7, then B will get 10. This is how the second option goes. The first option was A didn't get a 7, B got 10. Now what will be the next one? A has to fail, B has to fail, A has to fail, then B again has to fail, then A has to fail, then B is going to pass. Now this 7 is, we are calling it as A, PA's probability. So PA is 1 by 6, PA bar is 5 by 6, PB is 1 by 12, PB bar is 11 by 12. So these are the probabilities, intersection between them. You already know how do we do this? This is an infinite series. So geometric progression is going to be applied. Now I am separating them as we were doing with the independent events. With all these, whatever is inside probability with an intersection signs, we are separating them out. Now the third one, if you want to write, it's up to you. I don't have to write it because I know that how the series is going to go, but for the sake of completion, I'm writing it. It's not necessary. Those who have done this kind of question, they know that this is only optional. First and second term are very important as far as the geometric progression goes, because the first element will be 1, second element will be A, which is the common ratio. That is what we need to have. So PA bar is what? 5 by 6. So PA, wherever PA bar is there, just write 5 by 6. This will make your life easier. Rather than writing 1 by 1, wherever you get PA bar, write 5 by 6. Now wherever you get PB, take 1 by 12 and write it. This PB is 1 by 12. This one is 1 by 12. This is 1 by 12. Now multiply these wherever it is, and then add them all. Now this PB bar is remaining. Where is PB bar? What is PB bar? 11 by 12. So we got this 3. Now PB bar here 11 by 12. Then we again have PB bar, so 11 by 12 again. So this is 11 by 12. Now 5 by 6 multiplied by 1 by 12 has to be taken outside. So this, if it is taken, 11 by 12 into 5 by 6 will remain, and this is going to be your A, common ratio. The other, because two things have been taken, 5 by 6 into 11 by 12, you see twice. So it will be 11 by 12 into 5 by 6 square. So you can write it as 5 by 6 multiplied by 11 by 12 whole square. Plus, this goes on and on, infinite times. Now 1 plus A square till infinity is 1 by 1 minus A. So 1 by 1 minus A. A is what? 55 by 72. 5 into 11 is 55. And 6 into 12 is 72. 72 goes up. 72 minus 55 is what? Is 17. 72 by 17 is going to come. So you have to multiply this. 5 by 6 multiplied by 1 by 12 is multiplied by 72 by 17. So 6, 12 times 12 is already there. So only 5 by 17 is going to be your result. This comes out to be 5 by 17. This is your probability. Now there is a different way also of doing it. This is what I explained to you. It's important for you to understand the logic. Now this is what you have to go through, because you are going to ultimately write in this manner. Not identical, but you have to take encouragement from this only. Here the probability of A is computed and probability of winning B is subtracted from this. We followed a different approach. So the better is to find the probability that B wins directly, or if you want, you can follow this process also. Okay, this is all about this exercise. Thank you so much. Have a good one.